that got started. Disable annotation for others. Okay. And let me open up the charts. Okay. Yeah, 8 to 11. Class timing is still 11 o'clock, right? Okay. Yeah, module test will be told, right? It will be, coding questions will be there, certain MCQs will be there, everything will be conveyed to you. मतलब time रहते रहते बता दिया जाएगा. Don't worry on that. अभी try to focus on the learning and problem solving, right? Okay. So let's come here. Types of sorting is mandated in the industry. If you use sorting, you will be most probably using an arrays.sort. Okay. That is like the hard truth. A couple of sorting techniques are left, but for that we need recursion. So today we will be starting off with recursion. Okay. Cool, guys. So before even I start with recursion, right, I want to revise certain concepts of functions, right? So that, everyone is clear with the basics of function, because understanding functions is very important. Okay. Okay. Yeah. So where was I? Okay. खुद से logic नहीं बन पा रहा है. Yes, it will take time. It will take time, right? But I think practicing is the most important thing, right? Okay, we'll talk about this later. Okay, at the end of the class, I will take your personal doubts, like where you are struggling, what needs to be done. That can be taken up after the class. Okay. Sorting 3 techniques have been completed. There are 2 more sorting techniques that we have to discuss, but they employ recursion. So first of all, we have to understand recursion before even we go to, merge sort and quick sort. Okay. Chalo, cool, guys. Now let's get started, right? Let's get started. Okay. No more further spamming in the chats. Okay. Only content related to the lecture. Okay. So first of all, before even I start with what is recursion, right? First of all, I want to revise something about functions. Okay. We have studied about functions and I want to revise all about functions once again. So what are functions, right? Now, I told you guys that, boss, a function is nothing, right? It is like a block of code. A function is nothing, but it is a block of code that you can reuse again and again. So what is function? A function is a block of code, right? Which you can reuse again and again. And what did I tell you? Boss, you can treat your function as a black box. Okay, you can treat your function as a black box. And every function will have a name. Okay. Every function will receive certain parameters as input. It will have certain arguments. Okay. A function might accept something as input. Okay. So these are known as arguments of the function. So let us say the function basically takes an integer. So I can write here, boss, the function is expecting an integer int a. Okay. So it is expecting an integer as input or as an argument. Okay. Then there will be certain processing inside the function, right? Inside the function block, there is certain processing, and then you get certain output. Now the function can or cannot return something to you. Okay. So every function is associated with a return type. You have to specify what is the data type that my function is returning. Okay. And if the function is not returning anything, we say that the return type is void. Okay. So how did we write functions? We understood that, boss. First of all, by default, we are writing public static. Then I will write what is the return type of the function. If the function is not returning anything to me, then the return type will be void. But let's say if the function is returning an integer to you, it is returning an integer value. Then I will say, boss, the return type of the function is int. Okay. Then I write the name of the function. Let us say f name. Okay. And then within parentheses, I will write what are the parameters that my function is accepting. What are the arguments that you should supply to your function? Okay. So let us say public static, forget for now. You have to use it by default. Forget for now. Okay. So let's say that this function is receiving 2 integers. It is expecting 2 integers to be supplied as input. So what I will write? I will say, boss, this function is expecting 2 integers, int a and int b. So it is expecting 2 integers and I call them, I call these integers as a and b. Now, then within curly braces, you will do your logic. So let's say I find the summation of these 2 numbers, right? So I declare int sum is equal to a plus b. Okay. Now my question is, boss, This is this, and then I want to return the sum to the caller. Okay, so I write here return sum. So this integer data type, integer data sum will get returned to the caller. Okay, so this is the basic idea of a function. Every function has a return type, a function name, and the input parameters that you can supply to your function. You can have as many parameters, right? There is no upper limit like that. Okay, okay. Now, and if the function is not returning anything to you, then you can write the return type as void. Now, guys, try to understand, right? Now, what did I tell you? Whenever a function starts running, do you agree that a function context is created? Yes. So Vasudev, please try to join on time. It becomes very difficult to repeat and the flow gets broken, right? So we were just talking about the basics of functions, right? Ki, function is a piece of code block that you write once and then you can call this function again and again. You can reuse this block of code, right? And what did I tell? Every function has a return type that you have to specify. And if the function is not returning any data type, you write here a void. Then you write the name of the function. Then within parentheses, you write, okay, the parameters or the arguments that my function is expecting. Then within curly braces, you write your logic of the function and then you return something or you don't return something depending on if the return type is void or integer. Okay. Now, what did I tell you guys? First important thing is whenever you hit the return statement, okay, whenever you hit the return statement, that function's execution is terminated. Do you all agree? I'm just trying to recollect the important points that we will be needing. Whenever you hit the return statement, okay, the function's execution terminates. Okay. And what did I tell you guys? Whenever a function starts running, okay, let's say, how do you call this function? Let's say you have a main method, okay, and this main method is running. And inside this main method, you call this function fname, supply two integers, let's say 5, 8, and then you capture the answer in a variable. Okay. Now what will happen, guys? What is the first function that starts running? Whenever you run a Java program, what is the first function that starts running? The first function that starts running is the main method, right? It's the main method. So what happens? As soon as the main method starts running, what did I tell you? A context associated with the function will be created. A context, and think of the context like a block, which will contain all the important information associated with the function. Okay. And guys, we talked about scope, right? Ki any variables that you declare in the main method, they are only visible in the context of the main method. Okay. Mante ho? Any variables that you now see, let's say if I declare int b is equal to 5. Oh, sorry, let's take a different variable. Int x is equal to 5. Okay. And when you return from this, do you think this x will be visible in the main method? Never. So what I am telling is whenever a context, meaning of public static, please forget that for now. Please focus on what is being done. Okay. So first of all, the main method starts running. And as soon as the main method starts running, the context associated with the main method is created. Now, let's say what you are doing is you are printing, first of all, hello world, and then you are calling the function fname. And after calling this, you are again doing SOP done. Okay. So what will happen? The first line of main method starts running, which is SOP hello world. So hello world will be printed to the screen. Then I go to the second line of the main method, which is what? What is the second line? The second line of my main method makes a call to fname. So what is the main method doing? It is calling this function fname. So there is a line which calls the function fname and passes the argument as 5, 8. So what did I tell you guys? The moment you call a function, the context of the caller function is paused. Do you agree? The moment you call a function, the context of the caller function will be paused at this line. Yahan pe pause ho jayega. And what will happen? What will happen? The new context will be created. A context of what? A context of fname. Okay, a new context will be created. Because dekho na, the moment you call fname na, this main method will pause itself. Ye pause ho jayega. And this function will start running. So a new context of fname is created. And what is the value of a and b that it has got? Can anybody tell me? What is the value of a and b that it has got? 5, 8. So do you agree that inside the context of fname, A is equal to 5 and B is equal to 8. Do you agree? Yes. Acha. Let's say in the main method, you had a variable A equal to 5 and B equal to 8. And you have passed here A comma B. Can anybody tell me, is the A and B in the main method same as A and B that this function is getting? No. What did I tell you? Whenever you call a function and pass a variable, right? A copy of the value is passed. A copy is passed, right? So this A and B is completely different from this A and B in present in the context of the main method. Okay. Okay. So now A and B you got. Now what do you do? Let's say what am I doing inside fname? Int x is equal to 5. So the first line that runs is int x is equal to 5. And guys, help me understand. This variable x, it is local to this function. That is, this variable x is only visible inside the context of fname. Outside fname, nobody knows what is x. Okay, if I want to print x inside main, it will complain and it will tell me, boss, I don't know what x is. Okay, I don't know what x is. Okay, now what happens? I want to find the sum. So I do int sum is equal to a plus b. So now a new variable sum will be created and the value will be 13. And this variable sum is only visible in the context of fname method. Is everybody following till here? Yes? Yahan tak follow kar rahe ho? Now guys, try to understand. If I had made my return type as void, if I did not return anything back to the caller, then do you think you have access to the sum in the main method? Soch ke dekho guys. If you have computed the sum here and you didn't return the data type back to the caller, then you won't be you won't be having access of sum in the main method. So what do I tell? Boss, the return type of this function is int. So what I will do? After computing sum, I hit the statement return sum. And what happens? As soon as the return statement is hit, this function context will get destroyed. The function stops running. The function terminates. This function context will be destroyed. But it is returning the sum. So the value of this sum will be returned to the caller. So this context is destroyed, but it returns the value 13 to the caller. Now what happens? The value 13 is returned to the main method, right? Now what happens? The main method gets this value 13 and it stores it in the variable answer. So now the value of answer will be 13, which was the sum that was computed in the fname method. And then what you can do? SOP answer, whatever. Okay. And once SOP answer has been done and you come to the last line of the main method, then the main method will also stop running. So the context associated with the main method is also destroyed. Is everyone following this thing? If you want to return any two integers, yes. Benefit of destroying function. There is no benefit, right? But try to understand, boss. Every function has a context, this block. It is consuming some space, right? So once the function has been done, all the related information regarding that function is destroyed, right? See, once you leave the school, once you leave your school, all your data that was in the school server, that will be removed, right? Because you are no longer a current student. Then you become an alumni. Okay, so your data is moved. Okay. Okay, guys, just follow on what is being done. Is everybody clear with what is happening here? Who calls the main function? It is the job of Java. Forget that. Who calls? Somebody calls the main function. It is the job of JVM to call the main function. Okay. Okay. Can we write two returns? Guys, ek kaam karo. See, you all have doubts. I agree, right? But first of all, try to grasp the basics, right? Because all the doubts that you are having, 2 values return, 3 values return, these are very basic doubts which you can Google up and get it resolved, right? Sometimes we write return, void, and so. See, it depends on the logic, right? You write a return, int or and void, that depends on your logic. Okay. If you want to return some data to the caller, then you will have a return type, right? Otherwise, you have a void. Okay. Now, help me with this. Help me with this. So you have a main method. Okay, you have a main method, and I declare a variable int x is equal to 5. Okay, and then I call a method increment. I call a method increment. Yeah, I'm revising functions. I call a method increment and I pass the value of x here. Okay, and then I want to print the value of x. Okay, And what I am doing in the increment method, I'm just giving a basic definition. It receives a variable. Let me call this variable as a. Okay. And what it does is a plus plus. Job done. That is what this function is doing. Do you think you will actually see the value of x getting incremented? If yes, why? If no, why? No, you will not get it implemented, right? Because you pass a copy of the value of x, right? And this a is visible only inside the context of increment function, and you are not returning the value. So there is no changes that is being made to the variable x. Methods and functions are the same. Okay. See, int a is basically what? See, I am telling boss, this is a function increment, and this is expecting an integer to be passed as the argument. And I am calling that integer as a. See, try to understand. This is a person, right? This is a person. And he has a value x. This is a block, okay? And this block is storing 5. Okay. Now what he is doing, he is calling. See, this is another person, right? So he is passing this x to this person. Think of it like this is a function. Okay. So this person x is passing the value to this function. So you are passing a copy. So a copy of this block will be passed to the function. And this function can call this anything, right? A, B, C, D, whatever he wants, right? He does some activities. And if he returns something, then the caller will get access to it. Otherwise, when this function terminates, everything will get destroyed. Okay. No, if you return and you don't catch, then it will not get updated, right? Okay. So that is something about the basics of functions, right? Now I will give you one code and I will ask you all to share the output with me. What do you think will be the output? Okay. See, the reason why I'm spending time on functions is because many people had told they are unclear with functions. And I think functions is one of the prereqs for recursion, right? So that's why I'm spending some time. Can we use return and void? Definitely. Definitely. You can. Okay. You can. Return के बाद सीधा semicolon लगा दो. Okay. Okay. Cool. So help me with this thing, guys, right? Help me with what will be the output. I am writing a code and you guys will help me with the output. Okay. Now call F1. Okay. Then I'll write a F1 method, public static int. Okay, let's say it's not receiving anything as input. It's doing println. Okay. Just follow what I'm trying to do, right? अभी मत लिखो, मैं कर रहा हूँ, है ना? This will make most of the things clear, like how functions are actually working, right? Public static int, let's say, let's make it here void, right? Static int f2. Okay, guys. Can you help me? Yes, definitely. Definitely, you can. Why not? हाँ, इसमें कुछ return नहीं रहा, कर देते हैं. Let's. Okay. Can anybody help me with the output? Can anybody help me with the output? Can anybody help me with the output, right? Error. यार पहले तो रन करके देखते हैं एरर है या क्या है. ठीक है, it's saying error. Why? Because this statement is unreachable, right? This is unreachable, right? You return 1 here, so you will never come to this statement. So let us remove this from here and bring it down. Okay. Yes, guys. Now help me. Okay, चलो अपने लोग साथ में trace करते हैं, right? What will happen? So can anybody tell me which method starts running first? First of all, the main method starts running, right? So the context of the main is created, okay, and main method starts running. Now, what first word will be printed? Inside main before F1. This is printed, right? The first line is printed. Next, there will be a call to F1. There will be a call to F1. The moment this function F1 is called, the context of the main method is paused. And what will happen, guys? A new context for function F1 will be created. Now, what happens? This context starts running. What will be printed? Inside F1. Okay, inside F1. So now you will print inside F1. And then what will happen? You will execute this statement x is equal to F2. So the moment you make a call to F2, what will happen? The context of F1 is paused, right? And a new context of function F2 is created. Okay. Now F2 immediately makes a call to F3. So the first line is a call to F3. So the moment you make a call to F3, the context of F2 will be paused here and a new context for F3 will be created. Okay. Now you come inside the context of F3. What will happen? You are printing inside F3. So inside F3 will be printed. So this is the first line you see. This is the second line. This is the third line. Okay. Now, after printing this, what will happen, guys? Can you help me? F3 is done, right? So the context of F3 will be destroyed. And once the context of F3 is destroyed, where will you return? Where will you come back? You will come where you had paused last. Okay, so where had I paused? I had paused inside the context of F2. So I start playing again from here. What is the next line of F2? Return 0. So this context will be destroyed and 0 will be returned to the caller. Okay. So where will I start playing? I will start playing the context of F1. Okay. And F2 returns a 1. So that 1 will get assigned to X. Okay. So X is equal to 1. So I print 1. I print X that is equal to 1. So the fourth line will be 1. Yes. And then I will print, 0, 0. Yeah, return 0. Hai. So, 0 will be printed. Then I will print done with F1. Okay. And then I return 1. The moment I return 1, the context of F1 will be destroyed and 1 will be returned to the caller. Okay. Now F1 has returned a 1, but nobody is catching it, right? So nothing will be done. And then you go to the next line and you print after F1 in main. Okay. And once this line has been executed, the context of the main is also destroyed and your program is done. So let us try to run it and see what is happening. Okay, see what is happening, guys. Inside main before F1, the first line, then you made a function call to F1. So F1 starts running. You print inside F1. Then you make a call to F2. So you go to F2. Inside F2, the first call you make is to F3. So you go to F3. Then you print inside F3. Now you return from here and come back to F2. What is the next line? Return 0. So F2 terminate and it returns 0 to the caller. Okay. So 0 gets assigned in X. Then you print the value of X, which is 0. Then what do you print? Done with F1. Done with F1, right? Then you return 1. So the context of F1 is destroyed and 1 is returned to the main method, where F1 will return a 1. But there is no variable to catch this value 1. Okay. So you just move to the next line and you print after F1 in main. Okay. So is everyone able to understand the flow of execution of functions? Yes, is it making sense? See, the interesting part that you have to understand is the moment a function starts running, a context will be created for that function and that context starts running. Now, whenever you make another function call, that function context will be paused and you go to the new function execution. And when you return, the function context will be destroyed and you come back to the context where you had paused at the end. Okay, cool, guys. Not understood 0. It's just a return. It's just a return, right? It's a return 0 because the integer return type is int. You can return a 5 also if you want. That's nothing, right? Okay. Hi, Dharmendra, please go through the recordings. I think we have discussed a lot. Okay. I think just go through the recordings. That will be fine. Okay. So is everyone clear with this? I'll just go to this part. Just cast a vote here so that I can actually start on with recursion, right? See, in void, there is nothing to catch, right? In void, there is nothing to catch. If the return type is void, there is nothing to catch, right? So I'll just create this poll. Is everyone clear with the context creation? How the context is getting paused when a new function is created, right? What happens when you hit a return statement? The contexts are destroyed. Once the context is destroyed, where do you come back to, right? And the flow of execution of the functions. Is everyone clear with this? This is very important, right? This will help you understand recursion in a much, better manner. Okay. Yeah, okay. So most of you are clear, right? Most of you are clear, and that is good, right? That is good. So it's pretty simple, right? But I just wanted to, cover the basics before I actually move on with this thing, right? Okay. So anybody who is unclear, try to trace what the code is doing, right? Just remember that whenever a function starts running, a context is created and that context will be running. And whenever you make another function call, the context is paused and a new context is created. And when you return from a function, the context is destroyed. And where you come back to the context of the caller function. Okay, that's it. Pretty basic. Okay, cool. So I'll just stop the poll. You guys are becoming lazier by the day. Okay, cool. So that is about functions, right? Important thing. And when we do recursion now, this concept will be again getting revised. So don't worry, the 10% people who are not understanding, we will be again repeating this entire thing in recursion, right? So now once everyone is clear with what functions are, with what methods are, right? Now I will go to what recursion is. Now you will ask me, hey Adarsh, you wasted half an hour of our time, by discussing about functions. Why? Because recursion heavily uses the concept of functions. And that is why I wanted to make sure that all of you are clear with functions. Now, what is recursion? First of all, let me give you the definition of recursion, right? Let's say I'm writing a function. Okay, let's say you have a function and you are writing code for the function. Okay, and inside the body of the function, you make a call to the same function, right? The arguments might be different. The arguments that you supply, that might be different. But see, there is a function func. I am writing the definition of this function. You are writing the logic of this function. And inside the function body, you are calling this same function again. You are calling this same function again. In the previous example that we saw, right? F1 was calling F2, F2 was calling F3, main was calling F1. So the flow was like this. But this time what I am telling you, let's say that you are writing a function, okay? And inside the function body, you write all the logic and then you make a call to the same function once again, right? The parameters or arguments that you pass, that can be different, okay? But if this is the structure of the code that you are writing, then we call that it is recursion. So if I give you a formal definition of recursion, a function calling itself, okay? A function calling itself is called recursion. Very, very simple, right? Very, very basic, not simple, basic, okay? So a function, inside the function body, you make a function call, you make a call to the same function. That is what is known as recursion. A function calling itself is called recursion, okay? Now you will ask me, hey Adarsh, till now our life was pretty simple, right? We were learning about loops, we were learning about arrays, we were learning about all these things. Our life was pretty simple. Then you introduced functions and you made our lives a little bit complicated. But then I told you what are the advantages that are associated with functions. And then you accepted that, yes, a function is a very, very powerful tool, right? It is helping you to reuse your code and actually reducing your effort a lot. So, okay, you agreed with me that, okay, a function is important and we understood how functions are doing the job. But now you will ask me, hey Adarsh, why do I need such a case or where do I need such a case where a function is calling itself? ऐसा कौन सा situation आएगा where a function will call itself? Why do we even study recursion? Why it is important? So I will tell you in what kind of scenarios you can use recursion. Okay. So recursion is basically based on the principle of divide and conquer. Okay. So recursion is based on the principle of divide and conquer. So let us say that you get a very, very complex problem. Okay. Let's say somebody gives you a very difficult problem. So there are two ways in which you attack this problem. Either you raise your hands and you tell boss, the problem is very, very difficult. I cannot solve the problem. Or what can you do? There can be another approach of attacking and solving this problem. What will you do? You will say, okay, you have given me a very, very complex problem. But you know what can I do? I can break this problem into smaller, simpler sub-problems. मैं क्या बोलता हूँ, boss? The problem that you have given me, that is a very complex problem, but no problem. I can break it down into simpler sub-problems. I can break this complex problem into simpler and smaller sub-problems which are easier to solve. And then I will solve these smaller problems which are relatively easier. Okay. But I ask you a question that, boss, after solving these smaller problems, is your job done? You will say no. Why? Because my ultimate aim was to solve this bigger complex problem. So what do? I break this problem into smaller sub-problems. I solve all these smaller sub-problems. I get the answer to these smaller sub-problems, which are relatively easier. And once I have the answer to these smaller sub-problems, now I combine these answers to get the answer to the bigger problem that I have at hand. Okay. Now think of it like this, guys. Everybody has heard that story, right? You have a bundle of sticks. There was an old man and he gave a bundle of sticks to his sons, right? And he asked them to break it, right? Now, when the sticks were together, it was very difficult to break all the sticks together. So what did the, children do? They basically, employed a principle of divide and conquer. They separated the sticks, right? Every person took one stick and then he was able to break that single stick. So what was the principle that they applied? They divided and conquered, right? They divided the sticks into multiple parts and then they conquered their problem. That is, they broke their stick, right? So united we stand, divided we fall. So that is what we are doing. Boss, you cannot obtain victory over this complex problem as a whole. So you will be dividing this complex problem into smaller sub-problems, which are easier to attack and solve. And then you will be conquering these smaller sub-problems. And once you obtain the answer of these smaller sub-problems, you will somehow combine these answers to get the answer of the bigger problem that you wanted to solve. And that is what is the principle of divide and conquer. And in our real life also, guys, we tend to use divide and conquer a lot. And in these situations, right, in some of the divide and conquer principles, you can employ recursion because recursion is based on this principle only. Okay. So if you find these kind of problems, right, which can be broken into simpler problems, and once you know the answers of these, you know the answer to your bigger problem. So you will get a hint of, boss, this is nothing but a divide and conquer principle. And therefore you can employ recursion. And that is why we study recursion, right? Okay. Now, I'll just open the charts. Yeah, is everybody able to follow the intuition behind recursion, right? In what kind of situations recursion might be helpful for us? We'll see how, right? But these are the situations in which, recursion is helpful. And just to let you guys know, right? Can anybody tell me a very practical example of divide and conquer that we are using in our course structure? What have we done? Boss, mastering DSA is your complex problem. And you cannot attack and solve this complex problem in one go. So what have we done? We broke this problem into simpler sub-problems, module 1, module 2, module 3. And learning the contents of these modules is relatively easier. Okay. So you conquer these modules one by one. But boss, after conquering these modules, is your task done? No. The knowledge that you have learned in the individual modules, now, you will have to cross-apply them. You will have to cross-apply them so that you become a master of DSA. So in the course also, we are employing divide and conquer. Divide all the topics into small modules. Try to conquer the modules. And once you conquer the modules, you will intertwine your knowledge that you have gained in multiple modules to solve the bigger problem of mastering DSA. Okay. So long story short, divide and conquer is getting used at multiple places. Okay. You might know it or you might not. Okay. Let me give another example, and that will help us to understand a very, very important thing. Let me give another example of divide and conquer in our real life that people have seen, right? Now, let us think of a workplace, okay? Office, right? And there is a hierarchy that is existing in the office, okay? So how is the hierarchy? There is the boss. This is the boss, okay? Below the boss, think that you have, let's say, a senior manager, or let's say manager, okay? Below the manager, you have a junior, you have an employee, a basic employee, right? Non-manager employee. And below the employee, you have an intern. You have an intern. Okay. So this is the hierarchy that is existing in a workplace. Okay. Now, let's say that the boss wants the information of a particular file. Okay. Boss wants the information corresponding to a particular file. Okay. But the boss is very busy and he doesn't have time for that. So for the boss, finding the information of the file is a very, very complex problem. So what will the boss do? The boss will break his job into a smaller problem. The boss will go and tell the manager, hey manager, can you please find the information of the particular file for me? Okay. Now, if the manager doesn't want to, disobey the boss and he wants to maintain good relations with the boss, he will say, okay, boss, don't worry. I will get the information of the file for you. So guys, try to understand. The boss had a complex problem. He just broke the complex problem into a smaller problem. He just told the manager. And now guys, tell me, does the boss have to worry? What does the manager do? No. The boss will now simply sit and the manager will come back and give the information to the boss. But what will be the manager doing? Now, let's say for the manager also, this is a complex problem. He doesn't have time. So what will the manager do? The manager will again break his problem into a simpler problem. He will go and ask the employee, hey employee, can you please find the details of the file for me? What will the employee do? The employee will accept. But let's say that this is even a complex problem for the employee. He is also busy. So what he will do? He will go and pass on the problem to the intern. Hey intern, can you please go and give me the file information? Now the intern will accept because he wants a pre-placement offer, right? Now, can the intern pass on the information to anybody else? No. The intern is the base. The intern is the base and he has to do the work. Somebody has to get the information of the file. Otherwise, everyone will call each other and nobody will do the work. So the intern is the base case, okay, and he has to give you the answer. So the intern will get the file details and pass the information. See, the employee called the intern will do the job and he will return the information back to the employee. Now, the employee gets the information. Let's say he does some verification and he will return the same information to the manager. The manager in turn will return the same information to the boss. So what has happened, guys? The boss had called the manager, right? See, guys, at every level, the people don't worry what is happening below. The manager will tell to the employee and then the manager does not have to worry what is happening. The employee will solve the problem and get the answer back to the manager. Okay. Similarly, the boss is calling the manager and he doesn't have to worry what is the manager doing. The manager will ask somebody else. That is none of the boss's headache. The manager will do all the work, get the information and return the answer back to the boss. So is it not an example of divide and conquer? Everybody is dividing the problem into smaller parts till you reach a basic case. And this gives you the answer, returns the answer, and then the answer is propagated to all the levels. Is this making sense, guys? How many of you are able to understand? Yes? Okay. Take another example, right? Take another example. So, in this case, kuch nahi hua, boss. A complex problem was broken down into smaller sub-problems till you reach the base, and then the answers were returned back until you get the answer of the bigger problem. That is what is happened here. Now, if I give you another example, right? Let's say you have 1,000 papers. You have 1,000 papers, right? And the papers have names written on them. There are names of students written on the paper. And you want to sort the names. Okay, you have to sort the names. So what can you do? See, if an employee can't do it, then how an intern can do it? Time nahi hai na, boss. Employee doesn't have time, intern has time. Okay. Now, 1,000 papers you need to sort. Okay. So what I'm telling, this might be a very complex problem. But what do I tell you? In void functions, only SOP returns. Right. Only you do a printing, whatever. You don't return any data type, right? Now, let's say you have 1,000 papers and you want to sort them. So what can be one approach? Sort these 1,000 papers at one go. But another approach can be you divide the problem into smaller sub-problems. You make a pile of all the people whose name is starting with A. You make a pile of all the people whose name is starting with B. You make a pile of all the people whose name is starting with C. Okay, you divide it into smaller sub-problems. Then you solve these smaller sub-problems. You sort the A pile, you sort the B pile, you sort the C pile. Now, once the smaller sub-problems have been solved, what will you do? Below the A pile, you will place the B pile. Below the B pile, you will place the C pile. Likewise, you will place the piles one below the other. And then your entire goal of sorting the 1,000 papers name-wise, that will be achieved. So this is another example of divide and conquer that we commonly use in our day-to-day lives. Okay. Now let us come. Okay. So we all understand that yes, divide and conquer is something that we very commonly use in our day-to-day lives, right? So now let us see that yes, if we are using this principle so frequently, definitely recursion might prove to be helpful for us, right? So first of all, I want you to understand one thing, right? It's not related to recursion, but you know, I want you to do this. Let's say I'm writing a function, right? Void print. This is a function, okay? And what is this function doing? This function is first of all printing hello. Okay, this function is printing hello. Okay, and then I am making the call to the same function. So first of all, tell me guys, is this an example of recursion? Go to the definition of recursion. Is this an example of recursion? Is this a recursive code? Yes, a function calling itself, right? Inside the print, you are calling the print method. So this is purely recursion. Now, what will be the output? Can anybody guess the output? Can anybody guess the output? It will print infinite number of times it will print hello. Now let us try to understand what, and you will get some kind of an error known as a stack overflow error. Let us try to understand why. What happens, guys? The first time this print method runs, what will happen? A context associated with the print method is created. Achha, first of all, what is a stack, right? Pehle main batata hu what is a stack. Okay. So what is a stack, guys? A stack is a data structure. A stack is a data structure in which you can store information. Okay, and there is only one opening. Via this opening, you insert something, and via this opening, you take out something. Okay, so let's say you have inserted 1 in the stack and you have inserted 2. Okay, you have inserted 1 and on top of 1, you have inserted 2. Okay, then you inserted 5. Okay, now if you want to take out elements, first of all, you will get access to 5. Then you will get access to 2, then you will get access to 1. So what do I say? A stack is a LIFO data structure, last in, first out. The element that you insert at the last, that will be the first one to come outside of the stack. Last in, first out. Jo sabse last mein enter karega, that will be the first one to come out of the stack. So what is a stack? A stack is a LIFO data structure in which you can store numbers or whatever you want, right? Whatever data you want, you can store. That is what a stack is. Okay. Now let us try to understand what actually happens, right? Now, whenever the function runs, okay, whenever a function runs, right? What did I tell you? Whenever a function runs, a context associated with the function is created. Main bola tha na ye cheez. Whenever a function starts running, context associated with the function is created. And do you know what happens? Inside your memory, there is a call stack. There is a call stack. Okay. And whenever a context starts running now, it will be added to the call stack. This context will be taken and it will be inserted in the call stack. Let me tell you, let me take an example. Okay. So let's say you have this void print method. Let's try to trace what is happening. Okay. You are printing hello, SOP hello. Okay. And then you are making a call to the same function. Okay. That's it. Now let's see what happens, right? So from the main method, the moment you call print, what will happen? A context associated with the print is created. Okay. And let me call it as print1. Okay. Just to demarcate. This is print1. Let's say this is the context of print that is created. Okay. And this context starts running. So what will happen, guys? Hello will be printed to the screen. And then what is the second line? A call to print. So the moment you make a call to print, what will happen? This context gets paused. This context gets paused. Okay. And a new context will be created for print. Let me call this context as print context number 2 for your understanding, right? And again, now this context will start running. Okay. Now this context, when it starts running, what will happen? It will print hello. And then it will make a call another to print function. So this context will be paused and a new context will be created. Let me call it print3. So guys, do you understand what is happening? Every context is printing hello and creating another context. And that is printing hello, creating another context. So do you agree infinite number of contexts will be created? Because there is no point, there is no destruction of context happening, right? Now, what did I tell you? What happens? The moment a context starts running now, when the print one context was created, it will be added to the call stack. So print one is now running. Okay. Print one, this context is running. Now this context will run print hello, and then it will be making a call to another print. So this context gets paused and another context will be pushed to the stack or added to the stack. Let me call it as print two. This prints hello, then it will get paused and make another call to print three. Are you getting? So every time a new context is created, that will be added on the call stack. And guys, try to understand. This call stack is like a physical jug. Jada pani bharoge na, so it will start overflowing. Okay. So you are putting context one on top of the other. So at the end of the day, this stack will become full to the brim, and then it will give you, boss, stack overflow error. There is no more space to store the context inside the stack. Okay. What is the limit? We don't have to worry about that. Yes, call stack is also a memory. So are you guys understanding? No. See, try to understand. Whenever you run a function now, a brand new context is created. Whenever you call a function, there is an entire new context for the function that is created, right? And all the variables, everything will be a part of that context. It is not in the same context. That is one rule. Okay. The name is the same, but the context is physically different, right? That is why I write here na 1, 2 to differentiate. All the contexts are different. The names might be the same, but these are physically different. Okay. Now, guys, the problem here was nobody was terminating. The problem was nobody was terminating. Everybody was calling somebody else and nobody was doing the job and terminating. That is why the overflow happened. Think of it like in the office example, if everybody calls somebody else and nobody returns, then will the job ever be done? You will take infinite time, but your job will never be done. If everybody is calling somebody else, your job will never be done. Somebody has to do the job and terminate. Okay. So that is what is lacking here. The base is lacking here. Here, the intern was the base who was doing the work. But here, there is no base which will terminate my function. Okay. So that is why it gives you a stack overflow error. Okay. So after the second print line, if we break, where will you break? If you write break, first of all, break will be associated. If you write return here, now, still it is a infinite only. Because you print hello and you make a call to print, another context will be created. You print hello, another context will be created. You are never reaching to this return only, right? So only contexts are getting created. Okay. So whenever we write any recursive code, right? Whenever we write any recursive code, there are three important parts, or there are two important parts, let's say. There are two important parts that are associated with any recursive code that we write. The first and the very important thing, as every one of you have understood by now, is the basic case. Right? Acha, first of all, guys, मैं एक simple सा चीज कर रहा हूँ. Just I will want your agreement. Let's say if I'm writing code like this, F1, just for your clarity, right? Some lines of code, it calls F2. Okay. Then some lines of code, done. Okay. Just writing very small piece of code for checking your clarity. F2 में क्या कर रहा हूँ मैं? I am calling F3. Okay. And then in F3, what I am doing? I am just printing something. So what will happen, guys? First of all, and let's say from the main method, you call F1. So the context of F1 will be created and it will be added to the stack. Now the context of F1 is running. This is running. Play mode. Okay. So you print, then you call F2. The moment you call F2, what will happen, guys? This F1 context will be paused at this line. And what will happen? A new context of F2 will be created. Okay. And this context of F2 will be added in the stack. Okay. Now this context is running. What it will do? The first line is a call to F3. So what will happen? The context of F2 gets paused and a new context of F3 starts running. So it is added to the stack. Then what will happen? The F3 context runs fully. Function is done. Then I return. Now when I return from F3, what happens? The context of F3 is destroyed. That is, it is removed from the call stack. And when the context of F3 is removed, what is the next context that you can access? The context of its caller, which is F2. So now the context of F2 will start playing. Is there any other line in F2? No. So the context of F2 is also destroyed. Where do you come? You now start playing the context of F1. Okay, you start playing from the next line. Print, 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 or whatever these lines are. And then you reach the end of F1. So this context also gets destroyed. And then the call stack becomes empty. Is everyone able to understand this flow? If yes, then you are clear with how contexts are actually working, right? Great, great. Okay, cool. So now let's go to the two important. In F2, we have to return. If the return type is void, right? हाँ, जैसे गया वैसे ही घर आएगा, right? If you go from A to B to C, you will come from C to B to A, like this. Correct, correct. Okay. Now let's come to the two important parts that you have to keep in mind. Okay. Whenever you write any recursive code, there are two important parts that you want to keep in mind. What is the first important part? The first important part is the base case. Okay. We just saw now, without a basic case, you will have an infinite kind of a sequence, right? You will get a Stack Overflow error. So you have to have a base case. And what is the base case? Think of the base case like the simplest input. Think of it like the simplest input for which you know the answer. Okay. So for base case, for which you know answer. Okay. So aisa socho, boss, if everybody passes on the work to somebody else, you won't be doing, right? Somebody has to know the answer, right? If without calling somebody else, I know what the answer is. So for the base case, you know what the answer is, and you can simply return that answer without calling any other function. So what is the base case? Think of the base case like the smallest sub problem. Okay. The smallest sub problem for which you know the answer. So whenever this sub problem is called, you know the answer and you simply return the answer. You don't have to call anybody else. So base case is the simplest input, सबसे simple input जिसके लिए आपको answer पता हो. The smallest sub problem for which you don't have to call any other function and you can simply say, boss, I don't want to do anything, or this is the answer. You simply return. That is what is the base case. And a base case is extremely important because without a base case, you will run into a Stack Overflow error. Okay. So agreed that the base case is a very, very important part of any recursive code, right? What is the second important part? The second important part is, guys, what are we doing in recursion? We have a complex problem. Okay. I broke it up into a smaller problem. Okay. Then further, I broke it up into a smaller problem. And let's say I get the answer. Let's say the answer to this problem is alpha. Okay. But guys, tell me, getting the answer to this is not sufficient, right? Using this, I should get the answer to this. Let's say the answer to this is beta. And using this sub-problem answer, I should get the answer to my bigger problem. So what I am telling you is, you should know a relationship. Okay. Find the relationship. You should understand what is the relationship between bigger problem and smaller sub-problem. Now try to understand what do I say by this, right? Now, boss, I wanted to solve this complex problem, right? And I told you, okay, boss, go and solve this smaller sub-problem for me. Okay. This again might be a bigger problem. Then I say, okay, break it down and solve this smaller sub-problem for me. Now let us know the answer of this problem is 5. Okay. But by knowing the answer of this problem, how do I get the answer of this problem? I cannot get now. So I need to know a relationship between the smaller problem and the bigger problem. So let's say I tell you, boss, the answer to the bigger problem is 2 plus the answer to the smaller problem. Something like this. I know a relationship. So once I get the answer to this smaller problem, what will I say? The answer to this bigger problem is nothing but 2 plus 5, which is 7. And once I know the answer of this problem, I know the answer of my complex problem is 2 plus 7, which is 9. So what I want to say is, always you should understand what is the relationship between your bigger and the smaller sub-problem. Because at the end of the day, your goal is to solve the bigger problem. So once you get the answer to your smaller problem, you apply your formula or your relationship and you will get the answer to your bigger problem. And you can apply this formula or relationship at multiple levels so that you get at the topmost level and obtain the answer of the overall complex problem that we had at hand. Okay. How many of you are clear with this? Yes. Is this making sense? Yes. Following till now? Getting there धीरे धीरे, ठीक है? See what I am telling. If you try to understand, where two comes. See, I need to know the relationship between the bigger and the smaller problem. So मैं क्या बोलता हूँ, boss, let's say I want to solve this bigger problem, okay? And I say, okay, break it up into a smaller problem. I don't know the answer. Again, break it up into a smaller problem. I don't know the answer. Again, break it up into the smaller problem. Now I say, boss, this is the base case. This is the base case, simplest problem for which you know the answer. So I say, boss, the answer of this base case is nothing but, let's say, 10. 10 is the answer of this smaller subproblem. But only knowing the answer of this subproblem, is it enough? No. You want to know the answer of this one. Okay. So I need to know a relationship. Ki bhaiya, if I know the answer of the smaller problem, how do I get the answer of its immediately bigger problem? So if somebody tells you, boss, the answer to the bigger problem will be 2 plus the answer to the smaller problem. So I will know if the answer of the smaller problem is 10, the answer to this problem will be 2 plus 10, that is 12. Now, once I know the answer of this problem, I know the answer of this problem will be 14. And once I know the answer of this problem, I know the answer of the bigger problem, complex problem, is 16. So you need to know this relationship so that you can go all the way from the base to the top. Making sense? Yes? Recurrence relation, kind of, right? Cool. So that is what was the basic, okay, theoretical points that I wanted to cover, right? Now we will go for a couple of examples which will help you to understand recursion in a much more interesting format, right? And you go to any lecture, you attend any class, right? The two questions that everyone takes up for understanding of recursion is factorial and Fibonacci. And I will be not doing anything different, right? I'll be sticking to the same two questions because, you know, they are the best questions to make you understand recursion if you are a beginner, right? So let us start with the problem, factorial of a number. And I am pretty sure that all of you have done this problem using a for loop, right? That given an integer n, find the factorial of n and return the answer to me. Can everybody solve this problem using basic loops? Can everybody get the factorial of a number using basic loops? If no, then it's high time that you go back and retrospect, right? Because by now, you should definitely be able to get this. Okay, cool. So all of us know how to get the factorial of a number using for loops. Okay, but now I will tell you, boss, you have to employ recursion. So first of all, you know, first try to understand why even can I use recursion. Okay, so I ask you a question: what is 5 factorial? Okay, now see guys, I will do this entire question and then only I will open up the chats and ask for your clarity. Otherwise, you know, it becomes very difficult for me to focus on the teaching material, and the chats actually become a little bit diversive also, right? So I hope that nobody has a problem with chats being disabled. I will enable it to get your doubts, but when I do the concept, right? Okay. So if I ask you what is 5 factorial, everybody will say 5 factorial is 5 into 4 into 3 into 2 into 1. That is the basic mathematical definition that we have learned, right? But I can also say that, boss, 5 factorial is nothing but 5 into 4 factorial. This is also a relation that we have agreed and understood in maths. That is, n factorial is nothing but n into n minus 1 ka factorial. I am pretty sure that all of you are aware of this relationship that exists. Okay. And this relationship helps me to think recursively. This gives me an idea of divide and conquer. How does it give me an idea of divide and conquer? Now, let's say that somebody asks you, okay, you call a function. Let's say you call a function. Hey, can you, you are the main method, right? You are the main method. And you call, boss, can you please tell me the factorial of 5? Okay. You call this function and tell, hey, can you tell what is, you call this person and ask, can you tell me what is factorial of 5? Now, what this person say, boss, 5 factorial is a very complex task. But do you know what? I will ask somebody, can you give me the factorial of 4? He will call another person and say, boss, can you please tell what is 4 factorial? I call this person and say, hey, can you tell me what is 4 factorial? Okay. Now, what is this person telling me? Ye person mere ko bol raha hai, hey Adarsh, I have broken your problem into a simpler problem, right? You wanted me to find 5 factorial. That is a bigger problem. I break it down into a simpler problem. Can you find the answer of this simpler problem 4 factorial? Now, let's say somehow this person finds what is 4 factorial and he gives the answer as Ki boss, let's say 4 factorial is 24. Okay. Then what will this person do? He knows the answer of the smaller sub problem and he knows, boss, 5 factorial is nothing but 5 into 4 factorial. So what am I doing? When I want to find n factorial, let's say somebody asks me, hey Adarsh, can you tell me what is 99 factorial? I will say that person, boss, the problem that you have given me is very, very complex. But let me break it down into a simpler sub problem. If you give me the answer of the smaller sub problem 98 factorial, give me the answer of this smaller sub problem. Let us say he gives the answer as alpha. So what I will tell you, boss, I will multiply 99 with alpha and I will get the answer to my bigger problem. So is it not an example of divide and conquer? In order to find n factorial, this was a bigger problem. So I called a smaller sub problem of finding n minus 1 ka factorial. Now, once I got the answer to the smaller sub problem, I multiplied n and then I got the answer to the bigger problem. Okay. So think of it like this. Something like this will be happening. Ki boss, this is a person and he is expected to return the answer of 5 factorial. So what he will say? He will say, boss, what is 5 factorial? 5 factorial is 5 into, and then he will call another person. Ki, hey person, can you please tell me what is factorial of 4? He calls this person to find factorial of 4. Now this person says, boss, 4 factorial is a very, very difficult task. But you know what I will do? I know that 4 factorial is 4 into, he will call another person. Ki, hey boss, can you please find factorial of 3 for me? Can you give me 3 factorial? Now this person will say, boss, 3 factorial is too much for me. So what he will do? He will say 3 factorial is nothing but 3 into, he will call factorial of 2. He will say, boss, can you please find 2 factorial? What will this person say? Again, a complex task. So what is 2 factorial? 2 into, he will call another person and ask, boss, can you please find 1 factorial for me? Now this person says 1 factorial is difficult, but he will say 1 factorial is nothing but 1 into, he will call another person and ask him, hey, can you please give me factorial of 0? Now see guys, this person is my base case. This is my base, right? Because 0 factorial is the simplest input. It is a definition. You have to know the answer of 0 factorial. So this person will return, the boss, 0 factorial is nothing but 1. Now, once this person gets 1 as 0 factorial, what does he know? He will multiply 1 into 1, and he will return the answer of 1 factorial as 1. Okay. Now, once this person gets the answer of 1 factorial as 1, what he will do? He will multiply 2 with the answer. 2 into 1 is 1, and he will return 2 to the caller. Ye bolega, boss, 2 factorial is 2. Now, once this person gets the answer to 2 factorial as 2, what he will do? He will multiply 3 with 2 factorial, 6, and he returns the answer 6 to the caller. The boss, 3 factorial is 6. Now, this person was supposed to be calculating 4 factorial, and he had called this person for 3 factorial, and this person has returned the answer as 6. So what he will do? He will multiply 4 with the answer for 3 factorial. 4 into 6 is 24, and he will return this answer to the caller. Okay. Now, this person was expected to calculate 5 factorial, and he told that, boss, 5 factorial is nothing but 5 into 4 factorial. Okay. So he broke it up into a smaller problem. And now the answer of the smaller problem, 4 factorial, is available to this person, which is 24. So what this person will do? He will multiply 5 with 24. He gets the answer as 120. And he will tell me, boss, the answer of the complex problem that you gave me of finding 5 factorial is nothing but 120. Are you guys able to understand this flow? What is going on? Everyone is breaking the problem, right? एक को 5 factorial चाहिए, वो बोलता है भैया तुम मेरे को 4 factorial बताओ. If you give me 4 factorial, I will multiply it 5 and give you the answer, right? So everybody is trying to break it up into a smaller problem because I know कि boss 99 factorial is difficult. I tell you, boss, give me the answer of the smaller problem 98 factorial. You give me the answer as alpha. I know that I will multiply it with 99 and get the answer to the bigger problem. Yes. So this is a divide and conquer. If you can't divide it into simpler parts, then for sure you can't employ recursion, right? But yes, you understand this part. Okay, cool. Yes, recursion is black magic. I always tell my students, boss, recursion is black magic. Jadoo hota hai recursion mein. Okay. See the complex work. See guys, try to understand the beautiful magic. This person called this person for 4 factorial. And do you think this person is worried of what is happening here? This entire chain, is he worried of what is happening here in the entire chain? No. He will just wait for 4 factorial to give the answer. That is why a lot of things are getting abstracted. मेरे को worry नहीं करना है क्या चल रहा है detail अंदर. Okay, it's a black magic. Okay. So now let us try to write the code. Let us try to write the code for it, right? So first of all, the first important part that I want to understand is the base case. Okay. Can anybody help me with the base case? I want to find factorial of n. What do you think should be the base case? For what value of n, you immediately know the answer and you don't have to do anything. Can I say, boss, 0 factorial is the basic case? Dekh lo. Look at this example. Yes, 0 factorial is the base case, right? So I tell you, boss, the base case is nothing but if n is equal to 0, if the input is 0, you can simply return 0. Simple answer, right? If n is 0, just return the answer. You don't have to call anybody else. You just return 0. So this is the base case for the factorial function. Okay. There can be multiple base cases. You can also do like this. If n is less than equal to 1, return n. That is also fine. Multiple people can write different kinds of base cases, right? But the most simplest to understand is 0 factorial is 1. Okay. So when n is equal to 0, you simply return 1. That is the answer without even doing anything. Now let us try to understand how do we write the factorial function. So what do I write? Was the return type of the factorial function is int. Okay. Write the name, let's say fact, and it will be receiving an integer n. Okay. And think of this function like a black box, which will be performing back magic, right? So when you, let's say, call fact of 5, it will give you the answer. It will return an integer, which will tell you what is 5 factorial. Okay. So now let's say we are writing the logic for factorial of n. So first of all, what do I check? Before making any further calls, what do I check? Am I at a base case? First of all, always check for the base case. So I check if the input n equal to 0, that means it is a base case, and without doing any other function calls, I will simply return 1, which is the answer of fact of 0. So if you get an input as n equal to 0, you will simply return 1. That is the base case. Now, if you come to this line, I know that it is not a base case. So what will I do? I want to find factorial of n. So मैं पता है क्या करूँगा? I will say, boss, I will make a function called to fact of n minus 1. I make a call to fact of n minus 1. So what do I say? I call the fact function and pass a parameter of n minus 1. And what do I expect? This will return n minus 1 factorial to me. I don't have to worry how, right? This will return n minus 1 factorial to me. Now, once I get n minus 1 factorial, what will I do? I multiply with it. I multiply the answer of n minus 1 factorial with n. And what will this give me? N factorial. So I will simply return this thing. So see, sorry. So if you are not at the base case, what you will do? I will return what? I have to return the value of n factorial. Guys, try to understand. Fact of n is expected to return n factorial. So what am I returning? N into fact of n minus 1. So I call the function fact, pass a parameter n minus 1. So this will give me the answer of n minus 1 factorial. Then I multiply n with that. So I get the answer of n factorial and I return the answer to the caller. So fact of n will return the answer to n factorial. Now I ask you a very simple thing, guys. Is this an example of recursion? Definitely, right? Because within the fact function, you are calling the same function again. The argument might be different, but you are calling the same function. So definitely it is an idea of recursion. Is everyone able to understand this code? I'll do a dry run also. But is it making sense? Is it making sense? You have to return n factorial, right? So you call fact of n minus 1. This will give you n minus 1 factorial. Multiply it with n and return it to the caller. Why fact of n minus 1? Boss, what is n factorial? N factorial is n into n minus 1 ka factorial. So what am I telling you? You have a black box fact. You pass a number k and it will return k factorial to you, right? So I just pass n minus 1 to the fact function. So this will give me the answer to n minus 1 ka factorial. Multiply that with n and return the answer. Okay. Boss, what is 0 factorial? What is 0 factorial? 0 factorial is 1, right? Okay. Yes. Now we will try to trace. What actually happens in this code, right? Let us try to trace what actually happens in this code, right? We'll try to code in GDB as well. Don't worry. Factorial ka logic kahan likha hai? This is the logic. See guys, try to understand. What is n factorial? N factorial is n into factorial of n minus 1. How you are computing n minus 1 factorial? Forget it. But see, what is n factorial? N into factorial of n minus 1. So I have told recursion what is the logic, right? Okay. Now let us try to trace this code first of all, and then we will try to do an analysis. Okay. Let me write the code here briefly. Int. Yes, definitely. This is recursion, right? Because inside the fact function, you are calling the same function again with a different parameter. But ultimately, you are calling the same function, right? Okay. Dream abroad. First of all, join with your original name, right? Otherwise, I am not responding, right? Come with your original names. Otherwise, it becomes very difficult, right? People are coming with Death Note, Dream Abroad, right? Original names how? Enough. Okay. So let's come to this. Can we store n into n in a variable? Then yeah, you can store, right? You can write ki int answer is equal to n into factorial of n minus 1. Okay. And then you can return answer. That is also fine. But instead of storing, I am just, returning answer, returning n into factorial of n minus 1. Recursion is basically a function calling itself. So if you see the fact function is calling itself, I am making a call to the fact function, right? So it is recursion, right? So let's try to trace it. How to change name? Ruko. You will be able to rename yourself, right? Otherwise, you can like try to join once again. Okay. Okay, let's try to trace it, right? Let's try to trace what is happening, and then you will get better understanding. Okay. Chalo, karte hain. If n equal to 0, that is my base case, I will return 1. Okay. Else what? If it is not the base case, what will I do? I know that what is fact of n. I have called fact of n, right? I want the answer of n factorial. Fact of n is expected to give the answer of n factorial. And what is n factorial? N into factorial of n minus 1. So that is what I am doing. Return n into, I make a function call to n minus 1 factorial, right? So this will expect it to be giving me n minus 1 factorial, multiply it with n and return the answer to the column. So fact of n is nothing but n into fact of n minus 1. Now let us try to understand with an example how it is actually working, right? So let us take the value of n is equal to 5. N is equal to 5. Okay? So what will happen, guys? First of all, fact of 5 is called, right? First of all, fact of 5 is called, okay? So I am drawing here also, just making two different ways of you guys to understand. So the context of fact of 5 starts running, right? So the context of fact of 5 is added to the stack and it has started running. So what do you first check? You check, is 5 equal to 0? No. So you come to this line, and what is this line? Return. So what is the line here? Return 5 into, I make a call to fact of n minus 1. And what is n minus 1? N ka value is 5. So n minus 1 will be 4. So this context makes a call to return 5 into, it will make a call to fact of 4. And the moment you make a call to fact of 4, the context of f of 5 will be paused. And then what will happen? A new context will be created for fact of 4. And this context starts running. Okay. Now help me, guys. Yahan pe aap kahan pause hue the? I'm just drawing two ways. Return 5 into, you had paused at fact of 4. Now what will happen? A new context for fact of 4 is created and this context now starts running. Now what is the value of n inside this context? It is 4. So you first of all check. Is 4 equal to 0? No. So this is not the base case. So what is the line? Return 4 into, it will make a call to fact of 3. Okay. So what is the line that you are pausing on? Return 4 into, you make a call to fact of 3. Okay. So the moment you make a call to fact of 3, the context of f or 4 gets paused here at this part. It gets paused. And a new context for fact of 3 will be created. A new context for fact of 3 is created. Now the context of fact of 3 is running. The context of fact of 3 is running. So first of all, you check, is 3 equal to 0? No, so this is not the base case, right? So what you will do? You come to this line, return 3 into, and you make a function called to fact of 2. So what will happen? You come to this line, return 3 into fact of 2. And the moment you call fact of 2, the context will be paused here and a new context for fact of 2 is created and that is added to the stack. Okay. Now, I'm just drawing it both ways so that you understand it clearly. Now, fact of 2, a context will start running. Is 2 equal to 0? Definitely no. So what will happen? The line that it executes is return 2 into fact of 1. So it will call fact of 1. The moment you make a call to fact of 1, the context of fact of 2 will be paused here. A new context for fact of 1 starts running. That is added to the stack. Okay. Now, what do you do in this context? First of all, I check, is 1 equal to 0? Definitely no. So what you will do? You come to this line, return 1 into, and you make a call to fact of n minus 1. N is 1, so fact of 0. The moment you make a call to fact of 0, this context gets paused here. And a new context for fact of 0 is created and added on the call stack. Now guys, try to understand. The moment you see, you start running this call, function call or this context, what will happen? Is n equal to 0? Yes, definitely 0 equal to 0. So this is the base case. So you know what it will return? It will return 1 to the caller. So where it will return 1? I had paused at the context of fact of 1 here. So fact of 0 will be returning 1 here. And now this function will start playing once again. So what will happen? Return. I had paused at this line, right? So now return 1 into 1 is executed, which is 1. So fact of 1 will return 1 to its caller. Return, and it destroys here, right? So now I start playing fact of 2, and fact of 1 has returned the 1. So here 1. And what is the line that you start playing? Return 2 into 1. So return 2, and fact of 2 returns 2. So the context of fact of 2 is destroyed. Okay. And it returns 2 to the caller. Yahan se samjho ab. Hai na? What happens? Now the context of f of 3 will start playing at this line. So fact of 2 has returned a 2. So substitute 2 here. And what was the line that you had paused on? Return 3 into 2. So 3 into 2 is 6. Okay. So 3 into 2, 6 will be evaluated and this will be returned. So fact of 3 will return 6 to the caller. So you return 6 to the caller. Now what will happen? Now the context of f of 4 will again start running. Fact of 3 has returned a 6. So what is the line that you execute? Return 4 into 6, that is 24. So fact of 4 will return 24 to its caller. Okay, return 24 to its caller. Now this context f of 5 starts running. Fact of 4 has returned a 24, right? So what is the line that we will start resuming? Return 5 into 24, that is 120. So return 120 will be executed and f of 5 will return 120 to its caller. Okay. And that is how you get the answer of factorial of 5. How many of you are understanding? It's a little tricky to follow, but if you pay attention, you will definitely be able to understand what is happening. Understanding? See, this is like I'm trying to break it up into as simple as possible. So, yeah. Okay. So people are clear, right? So what has actually happened if you try to understand now? First of all, fact of 5 was called. Okay. Now, what did fact of 5 say? Ki boss, the answer is 5 into fact of 4. Okay. So then fact of 4 started running. Fact of 4 says ki boss, the answer is 4 into fact of 3. Now fact of 3 started running. Fact of 3 says the answer is nothing but 3 into fact of 2. Now fact of 2 starts running. What is fact of 2? Fact of 2 bolta hai, the answer is 2 into fact of 1. Okay. So fact of 1 starts running. Okay. Fact of 1 says the answer is 1 into fact of 0. Now forgive me for this. What have I done? Now fact of 0 starts running. This will return the answer as 1. Okay. So 1 into 1 is 1. So fact of 1 returns 1. 2 into 1 is 2. So fact of 2 returns 2. 3 into 2 is 6. So fact of 3 returns 6. 6 into 4 is 24. So fact of 4 returns 24. 5 into 24 is 120. So fact of 5 returns 120. That is what is happening. Yes. Yeah, this is kind of the recursion tree. I've messed it up, but this is the recursion tree, right? The f of 5 is calling f of 4. F of 4 is calling f of 3. F of 3 is calling f of 2. 2 is calling f of 1. F of 1 is calling f of 0. Then this returns answer. You multiply, everyone will start returning answers, right? You can return from 1 itself. That is also fine. Okay. Cool. Is this making sense? Yes. Okay. Now, first of all, guys, what is the time complexity? Let's do the time and space complexity analysis and then we'll go to the code, right? So what is happening? See, guys, whenever you try to analyze time and space complexity for recursion, always try to draw the recursion tree. So f of 5 was calling f of 4. F of 4 was calling f of 3. F of 3 was calling f of 2. F of 2 was calling f of 1. F of 1 was calling f of 0. So can you tell me how many function calls are made? How many function calls are made? Can anybody help me? Can I say n function calls are made? For finding n factorial, you make a call to n minus 1, then n minus 2, then n minus 3, then n minus 4. So can I say there are n different function calls that are made? Can I say it to you guys? There are n different function calls that have been made. And what is the work that you are doing in every function call? You check a if and you simply return. So can I say you are doing constant work in every function call? Can I say what are you doing in every function run? You check this if and you simply return, right? So is it not? Yeah, it's n plus 1. Chalo n plus 1 le lo, theek hai? So there are n plus 1 different function calls. And do you agree? Whenever you are running the context of a function, how much work are you doing? You check this if and you simply return, right? So every function context, you are doing constant work. Bolo, you check, is n equal to 0? No, then you simply do the return thing. So in every function call, you are doing constant work. And there are n plus 1 function calls. N plus 1 function calls. In every call, you are doing constant work, big O of 1 work. So is it not big O of n plus 1 or big O of n? Boss, n different functions run hua hai, n different function calls hua hai, and in every function you are doing constant work, right? So is it not big O of n? Yes. So the time complexity is big O of n. Okay. Now, what is the space complexity? What is the space complexity? Now, you might be in the impression ki boss, I am not using any extra space. But what I will tell you, whenever you write recursive code, na, this call stack which gets created implicitly, na, that will take some space. Do you agree? Boss, jo call stack aap create kar rahe ho na recursion ke through, that will store context and that will take up space. So in the worst case, how many contexts will you have in the call stack? F of 5, F of 4, F of 3, 2, 1, 0. And then the context starts getting removed. So can I say in the worst case, you will have n plus 1 context in the call stack? So definitely for the space complexity, it is also big O of n plus 1. Because n plus 1 context will be present in the call stack in the worst case, right? So the recursive code of the factorial function is big O of n time complexity and big O of n space complexity. But the iterative code took big O of n time complexity and big O of 1 space complexity. Okay, cool. Now let's go back to the code. Fatafat ek baar code karenge and then I'll gauge your understanding and then I'll quickly move on to, application of recursion. Either one a divide and conquer. I know that factorial of n depends on factorial of n minus 1. That's a smaller sub problem. So I can solve it using recursion, right? Let's quickly go to the, coding aspect. Online GDP पे ही कर लेते हैं. After this, we'll be doing the Fibonacci one, right? And उसके बाद do I have to उतना तो करते फिर देखते कितना time रहता है. Not sure how much time will be remaining. Okay. So first of all, I want to write the factorial function, right? So public, static, as it is. The return type of the factorial function, let's say, it's int only, right? I'll be doing for small values of n, right? So I'm writing the return type as int. What is the name? Fact. Okay. And it will be receiving an integer n. Okay. So fact, okay, when you call the fact function and pass a value n, it is expected to give me n factorial as the answer. So first of all, I check the base case. If n is equal to 0, okay, what will I do? I will simply return the answer as 1. Okay. Because 0 factorial is 1. Simply return the answer as 1. Now, see, even if you write an else here, that is fine. But you don't want to write an else. Why? Because if you get inside the if block, now you will, dekho, either you go in the if or you go in the else, right? So if you go in the if block, you will never come to line number 20. So you can skip writing an else here and simply do. Ki boss, when you are at line number 20, you are not at the base case. So what I will do? I have to give the answer for factorial of n. So जिसको ऐसे समझ में आता है ऐसे समझ लो. Int answer. What is the answer of n factorial? N into make a function call to fact and pass the value as n minus 1. So this will give me the answer of fact of n minus 1. Multiply it with n, store it in a variable answer. And then I will return answer to the caller because answer is what? N factorial. Okay. So this is the recursive code that we have written. Now, what I will do from the main method, let us say I want to find the factorial of 5. Int n is equal to 5. So what I will do, print ln, and I will simply call the fact function, pass it the value, let's say n, which is 5, right? And I'm expecting that it will tell me what is 5 factorial. And what is 5 factorial? 120. So let us run it and see. 120, right? Now if I take a bigger value, let's say 8, Okay, try to run it. I don't know what is 8 factorial, but you can check. Okay, 40320. Check kar lena, mere ko bhi nahi pata. Okay. So is everyone making sense with this? Let's go back to the Slido poll, right? No chats. Okay. Let's go to the Slido poll and take it, create a poll, MCQ. Are you clear? Greater than 70%. Okay, I'm writing 70% because recursion is little bit difficult, but let's see. So only yes and no options are there. Launch. Yes, guys. Can you please cast a vote? Everyone, please. I will request everyone to go and cast, because it's important for me to understand how many of you are grasping the concepts that are being delivered. And kitne log aise jin log ke like full upar se hi ja rahe, right? This is the chat that I have sent. Please, guys, there are more than 350 people. I expect around 200 of you go and vote, right? I expect ideally all of you, but I know that many of you are very lazy and you don't want to click on a link. But yes, please help me, guys. I want to get the demography of the class, right? Okay. So cool. It's pretty much as expected. I was expecting such kind of response only. It's 85-15, right? 85-15. Great. Okay. So cool, guys. I see that most of you are clear, right? And yeah, matlab, I am pretty much expecting that the 85% folks are lying in that category, that yes, if you try to do a dry run on a piece of pen and paper using context and all, you will become 100% clear, right? I assume you are in that category. Okay. So the remaining people, what I will ask you guys is, please try to take a piece of pen and paper and try to do a dry run. Try to understand what is fact of n doing. Fact of n is a magical black box. देखो ऐसे सोचो for the other people. Fact of n is a magical black box. Think of it like this. See if it helps in understanding. Okay. Fact of n. Fact is a magical black box, right? So I just call fact of n. I call fact of n. And what does fact of n do? Fact of n will say, okay, n into, it will call fact of n minus 1. Okay. Now this fact of n minus 1 might do many more calls. I am not interested in that, right? Recursion is like black magic, right? So I wanted to obtain factorial of n. It will say it is nothing but n into, and it will call factorial of n minus 1. Now forget whatever is the complex thing happening here in the right hand side. This will return the answer of factorial of n minus 1. Let us call it as alpha. You multiply that answer with n and you return that as factorial of n. So it is a black magic kind of thing. You don't have to worry with what is happening deep down, right? That is what happens. Okay. Cool, guys. Let me stop the poll. So, okay. So now I think we'll move to the next question, right? Which is the Fibonacci sequence, right? And yeah, don't worry if you don't 100% understand it, right? Yeah, you can use the return type as long if you have large values of n. Okay, you can do it, right? Space complexity once. Okay, I'll repeat it. See, space complexity, what is taking space? There is this implicit call stack which is storing the context, right? So what is happening in the call stack? If you understand, in the worst case, how many contexts are present in the call stack? There will be the context for 5, f of 5, f of 4, f of 3, f of 2, f of 1, and f of 0. Okay. So there are n plus 1 contexts in the call stack, and now they will start getting removed. So kitna space aapko chahiye in the call stack? It is big O of n plus 1. Because at max, there can be n plus 1 context, or big O of n, to be more clear. Right? And how big O of n? Time complexity? Because you are making n different function calls. And in every function, what are you doing? There is no for loop and anything like that, right? In every function, you are doing constant work. You are doing constant work for n different times in n different functions, right? So it is big O of n. हर function में constant work कर रहे हो और कितना function call की हो? n function calls you have done, right? Okay, let's go further. Yes, Srishti, everything will be done. How n function? Can you explain once? How are we coming out of this loop? Where are we coming out of the loop? How are we coming out of the loop? So Humedi, see, everybody is calling somebody else. Fact of 5 is saying 5 into fact of 4. Fact of 4 is saying 4 into fact of 3. Fact of 3 is saying 3 into fact of 2. Fact of 2 is saying 2 into fact of 1. Fact of 1 is saying 1 into fact of 0. Now fact of 0 is giving you the answer. And the moment you get the answer of fact of 0, what was this statement? Return 1 into fact of 0. So fact of 0 ka answer mila, you return 1 into fact of 0. So now everyone will start returning and you will get the answer at the topmost level. Okay. Cool. Let's move forward. Now we'll discuss the next question, which is again an important, right? Which is the Fibonacci series. Okay. See guys, you just want to understand recursion, so that the basics of recursion at least, so that you are, you are able to understand merge sort and quick sort. ठीक है? Recursion को black box की तरह सोचो, एकदम black box, right? कि boss, this box is, a magical black box, right? So I wanted to find factorial of n. I called this box. What does this box say? N into this will call another box fact of n minus 1. Now forget about how this thing gives me the answer. Magically gives the answer of n minus 1 factorial. You multiply it with n and this gives you the answer. So this is magic that is happening, right? But you understand that it is not magic and there is a lot of function calls that is happening in the backside, right? Cool. So let's come to the Fibonacci sequence. Okay, so what is the Fibonacci series, right? What is the Fibonacci series? So I think most of you must have studied about the Fibonacci series in maths, right? So the Fibonacci series goes like this: 0, then you have 1. Okay, the first two terms are 0 and 1. That is defined. Okay, and then the third term will be the summation of the previous two terms. So 0 plus 1 is 1. The next term will be the sum of the previous two terms. 1 plus 1 is 2. Then the next term will be 2 plus 1, which is 3. Then the next term will be 3 plus 2, which is 5. Then the next term will be 5 plus 3, which is 8. Then the next term will be 8 plus 5, which is 13. Okay. So the first two terms are defined as 0 and 1. And after that, every term is obtained by the summation of the previous two terms. So if I want to give you a mathematical definition of the Fibonacci sequence, so the nth Fibonacci term, f of n is nothing but the nth Fibonacci term. What is f of n? F of n gives me the nth Fibonacci term. Okay. So the nth Fibonacci term, f of n is equal to 0 if n is equal to 1. So the first Fibonacci term is 0 by definition. Okay. This is equal to 1 if n is equal to 2. The second Fibonacci term is 1 by definition. Okay. And otherwise, the nth Fibonacci term is nothing but what? The summation of the n minus 1th Fibonacci term plus the summation of n minus 2th Fibonacci term. So if I ask you what is the 10th Fibonacci term, you will say the 10th Fibonacci term is nothing but the summation of the 9th and the 8th Fibonacci term. See, what is this Fibonacci term? The summation of the previous two terms. So that is for all n greater than 2. This is the definition of a Fibonacci series. Is everyone comfortable with this definition? सबको पता है Fibonacci क्या होता है? Everyone is comfortable with this Fibonacci series definition? Yes? Okay, cool. Okay, repeat. It's nothing, boss. It's basically saying that the Fibonacci series goes like this, that the first two terms are 0 and 1. And then starting from the third term, every term is the summation of the previous two terms, right? It is the summation of the previous two terms. That's it. So if you look at the fifth term, what is the fifth term? Can anybody help me? What is the fifth term? Yn minus 1 and n minus 2. Okay. So Jyotirmai, if I ask you, what is the fifth Fibonacci term? If I ask you, this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. So I ask you, boss, f of 5 should give me the fifth Fibonacci term. So what do I tell you? The fifth Fibonacci term is nothing but the fourth term plus the third term. See, 2 plus 1, which is 3. So can't I say the fifth Fibonacci term is nothing but get the fourth Fibonacci term and get the third Fibonacci term, add them both up, and you get the fifth Fibonacci term. So the nth Fibonacci term is nothing but get the n minus 1th Fibonacci term, get the n minus 2th Fibonacci term, add them up, that gives you the answer to the nth. It's not like loops, I would say, but yeah, it can be used to simulate loops, right? Okay. So this is the basic definition of the Fibonacci series. Now, first of all, I ask you one question. Boss, why can I even do it using recursion? Why recursion? Can anybody help me? Why recursion? Anybody? Why recursion? Why recursion? Because we know the answer of the smaller subproblem, right? Because you are depending on smaller subproblems, right? Think of it like this. If somebody comes and asks me, hey Adarsh, can you tell me the 100th Fibonacci term? If somebody comes and asks me, hey Adarsh, can you tell me the 100th Fibonacci term? So you know what I will tell him? I will tell him, boss, this is a very complex problem. But you know what? I will break it up into two smaller sub-problems. I will ask you, can you give me the answer of the 99th and the 98th Fibonacci term? Can you give me these answers? And do you agree that finding the 99th term will be a simpler task as compared to finding the 100th term? Definitely, this is a smaller sub-problem, right? So I tell him, boss, you give me the answer of this smaller sub-problem, 99th and 98th. Now, I don't worry what is happening, how you are getting the answer. मैं बोलता हूँ, just give me the answer of these two smaller sub-problems, the 99th and the 90th term. Now, once I receive the answers to these smaller sub-problems, what will I do? I will simply add them up and I will tell boss the 100th Fibonacci term is alpha plus beta. Okay. So is it giving you an idea of divide and conquer? Now for the 99th term, you will depend on the 98th term and the 97th term. So everything is calling two more functions, right? What is meaning of destroy a function if take memory and takes more space? See, destroy a function means the context and the variables that are associated with that function context, right? That will get destroyed. Okay. Cool. So does everyone agree that yes, you can employ recursion to solve the Fibonacci? And see now, this relationship helps me to understand f of n is f of n minus 1 plus f of n minus 2. So first of all, help me guys. Can anybody tell me what is the base case here? If I want to write a function fib of n, which takes n and gives me the nth Fibonacci term, what are the base case or the base cases? What are the base cases for which you know the answer? You don't have to do anything. Boss, n equal to 1 and n equal to 2. These are my two basic cases for which I already know the answer, right? You don't have to worry anything. So if I first ask you what is the base case, the base case will be if n equal to 1. If you want to find the first Fibonacci term, right? Its definition, the answer is 0 return. Okay? One more base case will be if n equal to 2. If you want to find the second Fibonacci term, then you will return 1. Does everyone agree? These are the two smallest inputs for which you don't need to do any work and you know the answer already. So this is my base case. Now what do I tell? Base case समझ में आ गया. Now let's say you are writing a function, right? Let's say we are writing a function int fib int n, right? So it is taking a number n and it is expected to give me the nth Fibonacci term. Okay. What is the base case? The base case is the smallest value, smallest input for which you know the answer. Okay. So what I am telling, why didn't we take 0? Ramanuj, मैंने ऐसा किया है कि boss, I am starting with one based indexing. Try to think like this, right? This is the first term. This is the second term. This is the third term. So I am expecting that the user will give a valid value of n from 1. Okay. If he wants the first term, second term, third term like this, that is 1. And what is the base case? The simplest input for which you know the answer. Okay. What is the first term? It is by definition 0. You don't have to depend on anybody else. What is the second term? By definition 1. You don't have to depend on anybody else. So these two are my base cases. Boss, if n equal to 1, return 0. If n equal to 2, return 1. What is n? N is the term. Okay. So if n is equal to 5, I want to give you the fifth Fibonacci term. Okay. Now, when I come to this line, do you agree that we are not standing on a base case? We are not at a base case. If you would have been a base case, now you would have entered and returned. Okay. Now tell me what is the nth Fibonacci term. I know the nth Fibonacci term will depend on the n minus 1 and the n minus 2th Fibonacci term. So what I will say, I will call the function fib of n minus 1 and I will expect this runs magically and gives me the n minus 1th Fibonacci term. Plus, I will make a call to fib of n minus 2. So I call these two functions, expect them to give the n minus 1 and the n minus 2th Fibonacci term. Now, once they give me the term, let's say I add them up and store it in a variable answer. Okay. And what is this answer? This answer is nothing but the nth Fibonacci term. Because the summation of the n minus 1 and the n minus 2th Fibonacci term is nothing but the nth Fibonacci term. So we can simply next return answer because answer is nothing but the nth Fibonacci term. Is it making sense, guys? Yes. Making sense? Okay. Now let us try to trace. Okay. Let us try to trace what happens, right? Let us try to trace what happens in the code. How to print Fibonacci series using recursions. Karunga. Sab bataunga. Okay. How two functions work at the same time. Everything will be done. Don't worry. Okay. See, what is the second last line? I want to find the nth Fibonacci term. Think of it like this. Okay. Think of it like you want to find the nth Fibonacci term. You have called this box. Ki, boss, please perform your black magic and give me the nth Fibonacci term. Now, what does this box do? This calls fib of n minus 1. Ki, boss, please give me the n minus 1th Fibonacci term. Forget about all the complex logic that is happening. We will see that later. But assume that this gives me the answer of the n minus 1th Fibonacci term. Then it will call fib of n minus 2, another black box, and it will ask, can you give me the answer of the n minus 2th Fibonacci term? This gives the answer. Okay. Then it will add both the answers that it has received and it will return the added summation to the caller, which is the nth Fibonacci term. Getting? कि भैया देखो इस आदमी को तुम बोले हो what is the nth Fibonacci term? So he calls the person, asks what is the n minus 1th Fibonacci term, gets the answer. Okay. Then he calls another person, what is n minus 2th Fibonacci term, gets the answer, adds both of these answers and returns the answer to the caller. That is what is happening here, right? Now let us try to do a dry run over the recursion tree, and then we will be, able to understand and appreciate things in a much, better fashion. Okay. Now let's come here. Okay. So let's try to understand it. What will happen, right? So मैं code लिखता हूँ पहले तो यहाँ पे छोटे से. So int fib int 10. Okay. Just writing the pseudo code. First write the base cases. If n equal to 1, I return 0. Okay. If n equal to 2, I return 1. Okay. Otherwise, I can simply do a return. Okay. You can store it in a variable or do that is also fine. Otherwise, you can simply do return fib of n minus 1 plus fib of n minus 2. So both the function calls will be made, their answers will be obtained, addition will be performed, and then the result will be returned to the caller, which is the nth Fibonacci term. Okay. Now let us try to trace the contexts and everything that is happening, right? So we will be tracing out a recursion tree. Okay. How does the recursion actually work? Okay. So let's say that I want to run it for n equal to 5, right? I want to find the 5th Fibonacci term. Okay. I want to find the 5th Fibonacci term. So what will happen? From the main method, I call fib of 5. Okay. I am also drawing the call stack here parallelly and also trying to draw the tree. Okay. So first of all, fib of 5 will be called. So fib of 5 is present in the call stack. Okay. Now fib of 5 starts running. This context starts running, right? I want to find the nth Fibonacci term. So I check first. Is 5 equal to 1? No. Is 5 equal to 2? No. So this is not the base case. So what I will come? I will come to this line, return. And then I will say fib of n minus 1. The moment you make a call to fib of n minus 1, you will pause here. So where will I pause? I will pause at return. This line was getting executed, return. I will make a call to fib of 4. And here itself, the pausing will happen. So fib of 5 basically makes a call to fib of 4. Okay. It makes a call to fib of 4. It has just paused here. Okay. It has paused here only. Okay. Now, it has made a call to fib of 4. So what happens? A new context for fib of 4 is created. That is added on the call stack. Please guys try to follow this very, very carefully. Okay. Now fib of 4 starts running. Fib of 4 starts running. Is 4 equal to 1? No. Is 4 equal to 2? No. So this is not a base case. So what is the line that is starting? That will be executed return. And fib of n minus 1 means this will make a call to fib of 3. The moment this makes a call to fib of 3, you will pause here itself. So fib of 4 makes a call to fib of 3. And then what will happen? A new context is created for fib of 3. Okay. And this will be added on the stack. And this context now starts running. Is 3 equal to 1? No. Is 3 equal to 2? No. So what will happen? It will run a line return. It will make a call to fib of 2. The moment it makes a call to fib of 2, the context gets paused here. So it makes a call to fib of 2. A new context for fib of 2 is created and added on the stack. Okay. Now what will happen? This context starts running. This context starts running. Now, what is this? What is this? This is the base case. So when this context starts running, I will see is 2 equal to 1? No. Is 2 equal to 2? Yes. So this is the base case. So what will happen? This will return 1. This will return 1. So fib of 2 return 1. So fib of 2 will return 1 to the caller. It will return 1 to the caller. So this context is now destroyed. This context is now destroyed. Okay. Now 1 has been returned to the caller. So where was I? Where had I paused? I had paused at this fib of 2, and this fib of 2 has returned 1. Now, what is the remaining part of this line? Plus, then I will make a call to fib of what? N minus 2, fib of 3 minus 2, that is fib of 1. The moment I make a call to fib of 1, what will happen? Again, the context of fib of 3 will be paused. I make a call to fib of 1. Okay. Now, when I make a call to fib of 1, what will happen? A new context of fib of 1 is created and added on the stack. Okay. Fib of 1, the context added. Now, this context starts running. Okay. I will see that this is the base case. So, this will return 0 to the caller. This will return 0 to the caller. So, fib of 1 returns a 0. So, the context gets destroyed. And you will come here. You had paused here. Fib of 1 returns a 0. Now, what is 1 plus 0? 1 plus 0 is 1. And this line was return 1 plus 0. So, fib of 3 will return 1 plus 0, which is 1. Okay. So, fib of 3 will add these to 1 and 0. And it will return the summation 1 to the caller. So, fib of 3 also terminates. Fib of 3 also terminates, right? Now, what will happen? Now, where had I paused? I had paused here, right? So, fib of 3 has returned a value of 1. It has returned a value of 1. Now, what will happen? You will execute the remaining part of the statement, plus you will make a call to fib of n minus 2. So, now you will make a call to fib of 2. Okay. The moment you make a call to fib of 2, what will happen? This context gets paused here, and a new context for fib of 2 will be created and added to the top of the stack. Okay. Now what happens? Fib of 2 starts running. This is a base case. This is a base case. So this will return 1 to the caller. The context is destroyed and the context is destroyed and it will be returning 1 to the caller. So you get fib of 2 equal to 1 here. Now 1 plus 1 is 2. So this line will get executed. Return 1 plus 1. So return 2. So fib of 4 will now return 2 to the caller. Okay. And this gets destroyed. Now see guys, see the beauty. Fib of 5 had called fib of 4, right? And this entire complex process happened. But at the end of the day, fib of 4 returned the answer to fib of 5. Boss, this is the fourth Fibonacci term. Okay. So fib of 4 got evaluated to 2. Okay. Now, in order to find the fifth Fibonacci term, what will be my next step? The next part of this line will be plus fib of 3. I will make a call to fib of 3. And the moment you make a call to fib of 3, it will get paused. This context gets paused and fib of 3 context starts running. Okay. Now fib of 3 context will now run. Is it a base case? No. So fib of 3 will first of all call fib of 2. Is it a base case? Yes. So it will return 1 to the caller. Then what will fib of 3 call? It will call fib of n minus 2. That is fib of 1. This is again a base case. So it returns 0 to the caller. It returns 0. Now, fib of 3 has got the answers to fib of 2 and fib of 1. It adds both of them up. 1 plus 0 is 1. And it returns the answer 1 to the caller. So fib of 3 is 1. Now, fib of 5 had got the answers from fib of 4 and fib of 3. So it will add both of them up, 2 plus 1. And it will return the answer 3 to the caller. Now tell me guys first, how many of you are able to follow what is happening? Whether it finds first return, it will stop. No. See, the entire line is return x plus y, right? So first it will compute x, then it will compute y, then it will add them up, and then it will return. Okay. Confused? Okay, let me try to explain it once again, but not the tree alongside. Acha, theek hai. Let me repeat it once again, right? Just give me 1 second. 1 sec, guys. Need to note down. Just 1 sec. Yeah. ऊपर समझ आ गया, भीतरी में दिक्कत है. Okay. ठीक है. We'll try to trace it once again, right? Don't worry. See what is happening. Why I don't get? Have we exhausted our slides? No. See, if compiler find first return, then it will stop at that point. How could in function if so it is return f1 plus f2. So first a call will be made to f1. Okay, gets the answer. Then the call is made to f2, gets the answer. Then adds both of them, then returns. Okay. Why f1 plus f2 not happening together? Because what did I tell you? The moment you make a function call, the context is paused there. And then the new context start executing. So first of all the fn and minus n will be called, right? Okay, let me try to explain it once again in a simpler kind of fashion. Let me explain it, try to explain it once again, right? This is a tricky concept, right? And इसका time complexity में ना थोड़ा सा और देखना, मतलब it is what happened. The time complexity of this is even more tricky, right? Yeah, I will do once again. I will do once again. नहीं साथ में compute नहीं होता. That is the beauty, right? But you don't have to worry about the major parts of things, right? Okay. So see, let me write the code once again. भाई ध्यान से समझने का try करना, right? I'm pausing the chats once again. Everybody, please pay utmost attention. Okay. So fib in 10, it will give me the nth Fibonacci term. Okay. So I am checking if n equal to 1, I will be returning 0. This is my first base case. Okay. If n equal to 2, I will be returning 1. Okay. Else what I will do? चलो और थोड़ा एक और वे से समझाता हूँ. Let's see. Int answer is equal to fib of n minus 1 plus fib of n minus 2. This thing. Okay. And then I say, let's say return answer. ऐसे समझाने का try करता हूँ. Let's see if it makes any better sense, right? Now let's say I'm finding the fifth Fibonacci term because I don't have courage more to do n greater than that. It will be a long tree. Okay, to keep it simple, I'll take n equal to 5 only. Okay, so the fifth Fibonacci term. So what happens? I call fib of 5 from main. The boss give me the fifth Fibonacci term. So the context of fib of 5 starts running. I'm writing f in small, right? So f of 5 now starts running. This context for fib of 5 now starts running. Now what will happen, guys? Is 5 equal to 1? Is 5 equal to 2? No. So now this line starts running. Int answer is equal to. So answer is equal to. So first of all, the right hand side is evaluated. Now what happens? First of all, the call will be made to fib of n minus 1. The moment you see that the first term is fib of n minus 1, so what will answer? Answer is equal to fib of 4. And the moment I say fib of 4, I am making a call to the same function with a different value. So what happens? The context of f of 5 is paused here itself. यहीं पे pause हो गया ये, ठीक है? And a new context for f of 4 is created. And now this context starts running. First of all, you will get this answer to f of 4. Then only this f of 5 will proceed further. Try to understand, right? Now, f of 4 starts running. Okay. Now what happens? Is it a base case? Definitely this is not a base case. So you come to this line, answer is equal to, you make a call to fib of n minus 1. So you make a call to f of 3. The moment you make a function call, the context of f of 4 is paused here. Okay. And a new context for f of 3 will be created. यहाँ पे pause हो गया and the context for f of 3 is created. And this context now starts running. Okay. Is it a base case? Not. So it encounters this line, answer is equal to. And the first function call is made to f of 2. The moment you see a function call to f of 2, the line gets paused here. Okay. And a new context for f of 2 will be created. And this context now starts running. Now what is f of 2? This is the base case. This is the base case, right? So this is the base case and this will return what? 1 to the caller. So f of 2 simply returns 1 to the caller. This is the base case. Okay. So f of 2 wala context has been removed from here. Has been removed. This gets destroyed. Okay. Now, where will I resume from? I will resume where I had paused last. So I had paused at this f of 2. And what is this f of 2? This f of 2 is 1. Now, what is the remaining part of this line? Plus. Then I will make a function called to f of n minus 2. So what is 3 minus 2? 1. So I will make a function called to f of 1. So now f of 3 makes a function called to f of 1. See, first the left hand side is evaluated. Then only you will make a function called to the right hand side. Okay. So f of 1 is called. The moment you call f of 1. Okay. The moment, अब मैं यहाँ पे ना numbering दे रहा हूँ, just for your more clarity. The moment you call f of 1, right? This space is empty. This space is empty, right? So the context for f of 1 is created, added in the stack. And now this context starts running. And this is a base case. So this will return 0 to the caller. So this context is destroyed, right? Now f of 1 has returned a 0. So you get a 0 here. Okay. And then this line has been completed. So 1 plus 0 is 1 and 1 is saved in the answer variable. And what is the next line in f of 3? Return 1. So that line runs and f of 3 returns 1 to the caller. Okay. So this context is now destroyed. Okay. And 1 has been returned to the caller. Okay. So now which function will start playing? This one. F of 3 pe jahan pause hua tha, this starts playing. And f of 3 has given the value as 1. Okay. Now what is the next part of this line? Plus the function call will be made to f of 2. The moment you make a call to f of 2, this context f of 4 gets paused here. Okay. And a new context for f of 2 is created, that is added on the call stack. Okay. Now what happens? See, इधर ही add हो जाएगा because these two are not there. Empty f of 2 is added. Now what will f of 2 do? It is a base case. So it will return. What it will return? It will return 1. So this return 1 to the caller. Okay. So f of 2 has returned 1. Okay. Now what is this line? 1 plus 1 is 2. 2 gets assigned to answer. And you return answer in the next line. So f of 4 has returned the value 2. That is the fourth Fibonacci term is 2. Okay. Now what will start playing? This again starts playing. So fib of 4 has given me the answer as 2. Plus, I will next call what? Fib of n minus 2. That is fib of 3 will be called. Now from here I call fib of 3. Now what is fib of 3? The context of fib of 3 will be added here, let's say. Okay? Fib of 3 is added here. Now what will happen? This starts running. Is it a base case? No. So I will come to the line answer is equal to, and the first call will be made to f of 2 or fib of 2, right? This will get paused here. F of 2 starts running, right? This is the base case. This will return 1. Then what it will do? It will make a call to fib of 1. This is also the base case. It will return 0. 1 plus 0 is 1. So answer will be 1 and this will return answer which is 1. Okay. So fib of 3 has returned the answer as 1. Okay. And then answer is equal to 2 plus 1, 3. Okay. So for f of 5, the answer is equal to 3 and I will return answer in the next line. So f of 5 returns 3 to the caller. That is the fifth term is the the fifth Fibonacci term is 3. And if we want to verify it, the fifth Fibonacci term was indeed 3. Now tell me guys, how many of you understood this recursion tree? I don't know how to explain it in a more simple format, but yeah, I think most of you should have understood this part. Is it making sense? Samajh aa raha hai? And see, the beautiful thing is, you don't have to worry about this complex tree, right? I just call fib of n minus 1 and I expect, boss, this will give me the answer. Then I call fib of n minus 2, I expect this will give me the answer. Yeah, the dry run. This was the dry run, right? This is the dry run only by tracing. Okay. So, and see, the beautiful thing is, you don't have to worry about the complexity. Kya karo? I want to find the nth Fibonacci term, do the base cases, right? Then what will happen? I will just call fib of n minus 1. This tells me the, n minus 1th Fibonacci term. Call fib of n minus 2. This will return to you the n minus 2th Fibonacci term. Add both of them up. That is the answer to the nth Fibonacci term. Return this as the answer. Okay? Right? How to print entire series? Sochna thoda sa. Think. What's the time? It's 10 o'clock, right? So we'll do this question. Then I'll give you a break of 5 minutes. Okay? Cool. So this is the recursion tree. Now I ask you one question. How to approach other problems. Karenge bhai, sab. I will take different types of problems, right? See, recursion is complicated at the back end, right? But if you see, right, this is the black magic of recursion. If you just think it, upar se socho bhai, ki nth Fibonacci term nikalna tha, call fib of n minus 1. This will give me the n minus 1th Fibonacci term magically. Call fib of n minus 2. It will give you the n minus 2th Fibonacci term. Add both of them up. That is your answer and you return that answer as the nth Fibonacci term. Okay. Yes. You can even solve the Fibonacci term using loops. Okay. But and it's easier also using loops, right? See, I will tell you one thing. If you can do a question via iteration and recursion both, then we should prefer the iteration method, right? Iterative method, loop wala method. Why? Because in recursion, you always have that implicit call stack. And because of that call stack, you will be consuming some extra time and extra space, right? Because the context creation happens, context putting in the stack happens, context destruction happens. All these take up time. So recursive code generally takes longer time to run than iterative code. But then why do we learn recursion? Because in certain codes, whenever you solve certain problems, writing recursive code is very simple as compared to writing iterative code. So there we prefer to do an recursive code, right? But given an option, if somebody asked me that, boss, the code for both are similar. Iterative code is also simple enough, right? So always prefer iterative because recursion always has this extra overhead because of this implicit call stack that is being created and maintained. Okay. Now I will ask you one question before I go further and let us see, right? So I'll just draw the tree once again. We'll do the time and space complexity analysis, right? So let's draw the tree. Fib of 4 called fib of 4, this called fib of 3, this called fib of 2. Dhyan se sunna, right? 5 called 4, 4 called 3, 3 called 2. Now 2 returned, then you call f of 1, this also returned, 3 returned, f of 4 then calls f of what? 2. Returned answer, returned. Then f of 5 will call f of 3, f of 3 will again call f of 2, f of 2 will return, it will call f of 1, this will also return. Okay, and then you get the answer. Now, first of all, I ask you a very, not a simple question, but can you first help me with the space complexity? What do you think is the call stack space? But fib of 3 is already calculated. Why again calculate fib of 3? Chalo, good. So Puvili, what you have asked, right? I have already calculated here why again. So that is a drawback of recursion, and that exact same problem we solve in dynamic programming. Dynamic programming यही होता है कि boss in recursion, you are doing extra work. You have calculated f of 3 here. You again calculate f of 3 here, right? So basically you optimize this thing using DP beyond the scope at this point of time. Can anybody help me with the space complexity? How many contexts are present in the call stack in the worst case? Okay, so people are saying 2 raised to n to n minus 1. Okay, so what I will tell you, in the worst case, see what happens. You have the context of 5, then 4, then 3, then 2, right? So you have 4 contexts. Do you agree? 4 contexts hai. Then this f of 2 gets destroyed because this is the base case. Then f of 1 is added. So how many contexts are there now? Only 4 contexts, right? Then f of 1 get destroyed, f of 3 get destroyed, f of 4 aaya, then f of 2 gets added. So can I say the maximum number of contexts will be equal to the maximum depth of the tree? Maximum depth starting from the top till the bottom. The number of function calls that are there, that is what. So can I say the maximum number of contexts that will be there is 1, 2, 3, 4, right? So it is like n minus 1 context. Is it making sense? Height of the tree. Yes, I will give you a break of 5 minutes. 5 से 10 minutes का break दूंगा. पहले question complete करते हैं उसके बाद. ठीक है? Are you getting what I am trying to say? See, first of all, you added the context of 5, then you added context of 4, then you added context of 3, then you added context of 2. Then what happened? This context got removed. Okay? Then you added context of 1. This got removed. Then the context of 3 was also removed. Right? Then you added the context of 2. Base case, removed. Removed the context of 4. Okay. Then I added 3. 3 called 2. 2 was a base case, removed the context. Right? Now, okay. Then it calls 1, base case, removed. 3 got removed, 5 got removed. So how much space have you consumed at max? 1, 2, 3, 4. Dekho? At any given point of time, you never have more than 4 contexts in your call stack. Do you agree? No, it's not always n minus 1. It's n minus 1 for this case, right? See now, 5, 4, 3, 2, n minus 1, then 2 gets removed, 1 gets added. 1, 2, 3, 4, right? The maximum depth from the top till the bottom, that will tell me, right? So at any given point of time, in the worst case, right, you will have 4 contexts in the call stack. Tree depth, correct, tree depth, right? Dekho na, in one case, you can have this 5, 4, 3, 2, right? In another case, you can have 5, 4, 3, 1. You can have 5, 4, 2. You can have 5, 3, 2. You can have 5, 3, 1. All these contexts can be there. But if I tell you, ki boss, ek jug mein, you can have either 250 ml or somebody can fill 500 ml or somebody can fill 750 ml. So what will you say the worst case space complexity? 750 ml, na? Worst case space you need is 750 ml. So that is what I'm saying. In the worst case, the number of contexts that are present inside the call stack, that will be equal to the depth of the tree. Okay, start from the top. 5, 4, 3, 2. This is the depth of the tree. Okay. N minus 1 calls are there. Then this will be removed, then this. So, aapko dekhna hai what is the maximum depth of the tree. From the top, you have to get till the bottom, till the end. Okay. Making sense, guys? Does everyone agree? The space complexity is big O of n? Yes. I'll take 5-10 minutes more and then I'll give you a break, right? Achha. Now I ask you, what is the recurrence relation? Okay. We talk of the recurrence relation also, right? So, I say the time taken to find the nth Fibonacci term. What is T of n? T of n is the time taken to find the nth Fibonacci term. Can I say the time taken to find the nth Fibonacci term is the time taken to find the n minus 1th Fibonacci term plus the time taken to find the n minus 2th Fibonacci term plus some constant time for addition? Can I say? What is the time taken to find the nth Fibonacci term? If I ask you what is the time taken to find the 100th term, you will say whatever is the time taken to find the 99th term plus whatever is the time taken to find the 98th term. Okay. So this is what I call as the recurrence relation. Okay. And if you solve this using maths, okay, if you solve this using maths, you will see that the upper bound of this recurrence relation is 2 raised to n. Okay, the upper bound of this recurrence relation is 2 raised to n. But definitely, why will you agree with me like this, right? I have to give you certain proofs, right? And that is where comes a little bit tricky task of making it understand, right? I'll try to teach the time complexity in 2 to 3 formats, right? So whatever is more comfortable to you, you can try to digest using that. Okay. Now, first of all, what do I say? See, guys. So for 5, what did I do? 4, 3, 3, 2, 2, 1, like this, right? So if you look at the tree, see, I will try to help you guys in 2 to 3 different methods, right? Whatever you find more comfortable, right? So what exactly is happening, guys? There are, how many levels are there? How many levels are there? I will tell you 4 different ways of understanding the time curve. How many levels? N minus 1. There are approximately n levels, n minus 1 levels बोल सकता हूँ. There are 4 levels. And see, guys, try to understand. First, what do I need to do? For calculating the time complexity, what do we need to do? First of all, we have to count how many function calls are made. Do you agree? First of all, I have to count how many function calls are made. And then you have to see what is the work that you are doing in every function call. So first of all, tell me, what is the work that you are doing in every function call? What is the work? देखो तो यहाँ पे. What is the work that you are doing in every function call? Constant work? Is it constant work? You check if do an addition, return. Constant work you are doing in every function call, right? So first of all, I just need to count how many functions calls are there. If I can able to successfully count how many function calls are there, my job is done. My job is done, right? My job is done. So what do I tell you? What do I tell you? See, there are a couple of ways or 2 to 3 ways of understanding this, right? And after this, I will give you a 5-minute break, right? So basically, at every level, see, every level mein you are branching out twice, right? So you are here, you go down, you have 2 options. Again, you go down, you have 2 options, right? So at every number, you are branching out 2 times. You are branching out 2 times, right? And there are n levels. So it is 2 raised to n. At every level, you have two options. So at n levels, you have 2 raised to n. Okay. At every level, you just multiply 2, right? You come to this level, multiply 2. Come to this level, again, you have two options, multiply 2. Again, you come to this level, two options, multiply 2, right? So this is 2 raised to n. This is the upper bound, right? This is the upper bound. Okay. Another way to understand the same thing is I'll give you 4 different ways, right? मतलब मेरे को तो चारों सही लगता है. See, let's see what you understand, right? Now let's say if I tell you f of 5, okay, f of 5, what it will do? It will call f of 4, f of 3, ऐसा कुछ tree बनेगा. Does everyone agree? F of 5 will lead to a tree like this. Yes. Now, if I increase the value of n by 1, let's say f of 6, what will f of 6 do? F of 6 will have this entire tree of 5, this entire tree, and it will have the tree for 4. Okay. And approximately 5 and 4 trees can be taken as equal. Approximately 5 and 4 ka trees you can consider the same. So as I increase the value of n by 1, okay, the number of calls are doubling. See, this entire tree will be there, and then you will have this tree of 4 also. So the number of calls are basically doubling, right? So with every increase in value of n, you are doubling the number of calls. So for n value, you know, double कर रहे हो तो into 2 हो रहा है. Okay. So n calls are there. So 2 into n. Sorry, 2 raised to n. Right? That is another way. Now, the way that I understand it and I feel most comfortable, right? ये भी दोनों अच्छा तरीका है, right? But this requires kind of intuition. कि with every increase in value of n, your number of function calls are getting doubled. Double हो रहा है, right? So for n equal to 1, it is 2. For n equal to 2, it went to 4. For n equal to 3, it went to 8, then 16. So it is 2 raised to n. One way of it, this is understanding. The other way was there are 2 options at every level. Okay. So there are n levels, 2 options at every level, 2 raised to n approximately. Right. Now, one more way of understanding this would be, see guys, what is the worst case? Worst case is basically an upper bound. Do you agree? What is the worst case time complexity? An upper bound कि भैया इससे ज्यादा तो नहीं लगेगा. ठीक है. So let's say if something is 10 minutes, okay. So if I say that the upper bound is 11 minutes, am I wrong? Am I wrong? No, I'm not wrong, right? If I say, boss, you have a function, let's say something like this. अगर मैं ऐसा बोलता हूँ कुछ कि boss, there are two curves, right? कि दिस मैं ऐसे ही रैंडम बना रहा हूँ, दिस कर्व इज 2 raised to n by 2, ओके, एंड दिस कर्व इज 2 raised to n. आई एम जस्ट ड्रॉइंग फॉर योर अंडरस्टैंडिंग, राइट? एंड आवर फंक्शन लाइज समवेयर इन बिटवीन. मेरा फंक्शन कुछ ऐसा है, ठीक है? तो इफ आई वांट टू गिव यू द अपर बाउंड, व्हाट शुड आई से? इफ आई से इट इज बिग ऑफ 2 raised to n, इज इट रॉन्ग? नो, इट इज नॉट रॉन्ग, राइट? लेट्स से एक लोअर बाउंड है 2 raised to n by 2 and the upper bound is 2 raised to n, and my function is somewhere lying in this range in between. So can I say the upper bound is 2 raised to n? Because this function never exceeds 2 raised to n, right? So I can say that the worst case is 2 raised to n. Okay. So now I will tell you the mathematical way in which I understand simply. Okay. So see. Now we were looking at n is equal to 5, right? N is equal to 5, right? N is equal to 5. So what it was doing? It was making a function called to 4, then 3, right? This was making a function called to 3, then 2, right? Then it was making a function called to 2, then 1, like this. This was the original tree. Everyone agrees this was the original tree. अब मैं क्या बोल रहा हूँ? I want to do an upper bound estimation, right? I want to do an upper bound estimation. So for my simple understanding, what will I do? I put some more. I assume कि चलो कुछ और extra function calls हो रहे हैं. I don't care. I just assume that there are some dummy function calls being made. ये नहीं हो रहे हैं, right? But I am trying to get an upper bound. So now can I compute the number of function calls? Let's see. 1 plus 2 plus 4 plus this. So see, 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3. Likewise, till 2 raised to n minus 1. Do you agree? There will be n minus 1 different levels. मानते हो क्या? In every level. See guys, I am giving you an upper bound analysis. ठीक है? या तो ऐसा सोचो guys. For 5, you are depending on 4 and 3 now. Okay. See, there are two ways again of understanding this thing. See, 5 was depending on 4 and 3. 4 depended on 3, 2, 2, 1, something like this, right? So, what I am telling is, add some more number of function calls, right? See, this 2 is calling again 2 functions. This 2 is calling again 2 functions. This 1 is calling again 2 functions. They are not calling, agreed. But let's make them, right? Let's make them for our understanding, right? So अब मैं क्या बोलता हूँ? How many levels are there? See, there are 4 levels, right? There are 4 levels. So there are n minus 1 levels. So how many function calls are made in this level? 2 to the power 0 plus in this there are 2 function calls. So 2 to the power 1 plus here how many function calls are there? 2 to the power 2 plus here how many function calls are there? 2 to the power 3. So can I say it is basically nothing but 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3. ऐसे करते करते there are n minus 1 levels. So 2 to the power n minus 2. Do you all agree? This is the number of function calls in the worst case. Upper bound, taking some extra function calls. Do you agree? देख लो 2 to the power 0, 1, 2, 3. What is 3? N minus 2. Do you all agree? It contains some more number of function calls, right? But I don't care. I am obtaining an upper bound. Can anybody give me the summation of this? Anybody? Can you help me with this summation? नहीं, 2 का power n minus 1 नहीं होगा because see, for 5 you are coming till 2 raised to 3, right? So this is n minus 2. N was 5, right? So you are coming till 2 raised to n minus 2. Now this is a GP, right? What is the first term, guys? The first term is 1. What is the common ratio? R is 2. And what is n? How many terms are there in total in this GP? There are n minus 1 terms in total. So what was the formula? A into R raised to n minus 1 by R minus 1. Do you agree? So what is R raised to? N is this minus 1 by R minus 1. So what is it? This is 2 raised to n minus 1 minus 1. Okay. Again, ignore this. What is 2 raised to n minus 1? Can I say it is nothing but 2 raised to n by 2? यही होता है ना, 2 raised to n by -1 क्या हुआ? 2 raised to n by 2. Remove this constant. So is it not big O of 2 raised to n? Are you understanding what I'm trying to say? Just make some dummy function calls so that it helps us to understand the time complexity in an easier fashion. This is the upper bound. This is the upper bound. ठीक है? Another way of understanding the same thing, बहुत लोग ऐसे भी बताते हैं कि boss for 5 you are depending on 4 and 3 ना. So I will replace this 3 with 4 itself, right? So 5 was depending on 4 and 4. ज़्यादा time कर दिया, कुछ नहीं. 3, 3 ऐसा कुछ, right? I'm just taking more time now. Okay? Same thing. वही dummy function calls ही हुआ है यहाँ पे. Okay? What I'm saying, see, 5 was dependent on 4 and 3 now. But what I want to approximate the upper bound. So let us say that 5 is dependent on 2 times 4. Because the time that is taken to evaluate 4 is greater than the time taken to evaluate 3, right? So you can understand like this also. Okay. See, it's a complete binary tree. Okay. Same thing. How many levels are there? There are this thing. Okay. Achha, and what will be the lower bound? This was the upper bound, right? Big O of 2 raised to n. Our interest is this only. Are you clear with this, guys? 2 raised to n minus 2 कैसे हुई ये नहीं समझ में आया. See ना, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. What is n? N is equal to 5. And here I am adding 2 raised to 3. So what is 3? 3 is nothing but n minus 2 ना. देख लो, example से दिखाया हूँ. Okay. See, this actually takes a little bit of time to understand. Okay. क्योंकि देखो ना, मैं क्या बोल रहा हूँ. What is my worst case analysis? My worst case analysis is upper bound ना. तो मैं क्या बोल रहा हूँ बॉस, अगर let's say you थोड़ा ब्रेक दे दो. अच्छा लास्ट just 2 minutes guys. मैं एक बार बस लास्ट ट्राई कर रहा हूँ क्लियर करने का हिंदी में बोल के. Then I'll say. See, this is the best way to clear, right? 5 depends on 4 and 3. 4 calls 3 and 2. 3 calls 2 and 1. Okay, this 3 calls 2 and 1. Now what I'm saying, try to understand guys. How many function calls are there? मान लो this is 1, 2, 3, 4, 5, 6, 7. See, the number of circles that I have drawn, are they the number of function calls? मानते हो क्या? जितना circle है उतना ही function call हुआ है. So let's say there are alpha number of function calls. Okay, and every call is doing constant work. So I can say that the time complexity is big O of alpha. But मेरे को ना alpha compute करने में दिक्कत हो रहा है. So can I say if I give you a number beta that is greater than alpha, मैं बोलता हूँ बॉस 10 फंक्शन कॉल हो रहा है, बट कोई बात नहीं, मेरा एस्टिमेशन बताता है 15 फंक्शन कॉल्स. इट्स एन ओवर एस्टिमेट, बट आई कैन से ना कि इट इज बिग O ऑफ 15 और बिग O ऑफ बीटा. अपर बाउंड है ना बॉस, अपर बाउंड. See, if somebody is telling you there are 10 function calls and every call takes 5 minutes, okay, so the code is taking 50 minutes. But for my analysis, I can do it simply ना. अगर मेरे को simply पता चल रहा है there are 15 calls, okay, this is an over approximation. And every calls take 5 minutes. I can say now the upper bound is 75 minutes. बोल ही सकता हूँ. Not a problem, right? So what I'm telling, assume that there are some dummy function calls here. Assume for our simple analysis, right? थोड़ा ज्यादा फंक्शन कॉल हो गया ना तो कोई प्रॉब्लम नहीं है, राइट? अपर बाउंड अल्टीमेटली. So just assume there are some dummy function calls here. So how many total function calls are made? Here 1, here 2, here 4, here 8. So what has happened? What has happened? 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3. Okay. And what was the value of n? N is equal to 5. Okay. So what is this level? This is 2 raised to n minus 2. So if you add this up, 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 till 2 raised to n minus 2, you will see that this summation comes out to be 2 raised to n. So the upper bound is big O of 2 raised to n. Okay. Making sense, guys? देखो 2 raised to n से थोड़ा सा कम ही होगा, but for our approximation and estimate it is 2 raised to n because that is a strict upper bound. Okay, there is a lower bound also, but I don't think I will say it at this point of time. You will get more confused, right? So remember the upper bound only because that is only mostly used, right? But I'll share an article with the mathematical analysis, but I found it the most convenient way to understand. मेरे को तो ऐसे अच्छे से समझ में आता है. So I thought that yeah, I'll share it with you guys. Okay, cool guys. So we'll have a break. 2 raised to 1 नहीं समझा क्यों नहीं भाई? 2 raised to 0, this is one function call. When you go to the next level, you have 2 raised to 1, 2 function calls. Here you have 4 function calls, which is 2 raised to 2. Here you have 8 function calls, which is 2 raised to 3. वही किया है ना? Yes, every function is calling 2 functions, correct? Okay, so I'll stop the chats. Right? Yeah, I will go to the previous slide. It's a break of 5 minutes, guys. It's a break of 5 minutes. Nothing, boss. 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 till 2 raised to n minus 2. How many different terms are there in this GP? N minus 1 different terms are there. And what is the formula? A into R raised to number of terms minus 1 by R minus 1. The common ratio is 2. You are multiplying by 2 every time. So 1, the first term is 1 into R is 2. The total number of terms here is n minus 1 minus 1 by 2 minus 1, which is nothing but big O of 2 raised to n minus 1 minus 1. Drop the constant. Big O of 2 raised to n minus 1. What is 2 raised to n minus 1? 2 raised to n by 2. Okay, maths. So again, drop the constant. It is big O of 2 raised to n. So the time complexity of Fibonacci is big O of 2 raised to n. And the space complexity is big O of n. Okay. Now we have a break of 7 minutes. We'll start again at 10:30. Okay. We'll try to take a couple of questions, right? Okay, let's make a Slido poll also. Thoda difficult, I agree, right? It is a little bit complicated for sure. But yeah, if you understand it properly enough, फिर भूलोगे नहीं. Okay, I think. Okay, so this is the last vote that I can have today. This time I'll add an extra option here. Yes, no, almost there. Everyone knows the meaning of almost there. So let me save it up. Copy the link. Everyone, make it go live. Live. Okay, guys, just please vote it out. Okay. देखो, I have tried to break it down into a simplest format, right? The topic ही ऐसा है कि थोड़ा सा ही difficult रहता है, but I have tried to break it into simpler, format so that everyone is able to follow at least what is happening, right? That is why I gave you this idea, right? That is why I gave you this idea. See, कि मेरा जो time है ना, that is somewhere in between, right? The upper bound is 2 raised to n, because 2 raised to n जब मैं approximate कर रहा हूँ ना, if you see, I have added some dummy functions here which are not being called. So actually this approximation is greater, right? इतना time नहीं लगेगा, but this is like the upper bound. So in big O we actually say the nearest upper bound, which is 2 raised to n. Okay, let's look at the polls. Okay, cool. So almost there and this. So if I add it, it's coming up to approximately 80%. ठीक है, cool guys. So yes, and almost there, people. Try to help the remaining 18% folks, right? And guys, try to get your doubts clarified. Whatever doubts you are having, DM me on Discord, right? आज मैं Discord नहीं देखा सुबह से, so apologies for that. But I'll have a look at it tonight or tomorrow morning maybe. And yeah, I try to get back to most of the questions that you guys asked, right? So please, and yeah, communicate with each other also and see whether people are understanding concepts. If your friends can also help you to understand, right? Okay, guys. So yeah, 5 minutes. I'll also take a break and not disturb you guys. Okay. This poll is live. Remaining people, if you want to vote, you can, right? I'll just take a break of 5 minutes. Okay, I'll pause the recording for 5 minutes. Otherwise, it becomes unnecessarily long. Yes, we will take questions in LeetCode also. So in the test, right, you will have function completion problem, right? So you will be given the definition of a function. Ki boss, this function has received an integer and this should be the return type. You just have to write the logic and return. You don't have to care about taking inputs, printing to the screen, nothing. You just have to write the logic of the function, assuming that you already have inputs in the function, and you just have to return the final output. That is how the things work, right? We will see this. Yes, correct. Okay. If you wrote half of the program, you have to pass test cases, right? If you pass half the test cases, you get half the marks, right? ऐसा नहीं होगा कि कोड आधा लिखोगे तो कैसे मिलेगा भाई? Yes, I am trying to take up more questions on functions, right? See, once we are done in till Friday, right? See, if you remember my timetable, right? This Thursday and this Friday is entirely problem solving, right? So there we will cover good questions also. And after that, if you want more problem solving, Saturday and Sunday is there, right? But yeah, from Saturday, Sunday, your self-practice time will start. You will get approximately 4 to 5 days of self-revision, right? Okay. Cool, guys. So I think we can move ahead. How can we explain a logical interview? Even I understand, I can't explain in a good way. So Arun, the best way for while one kab tak chalta hai? While one is an infinite loop, right? Unless you specifically break out, it is an infinite loop. Okay. So Arun was asking, how do you explain? So the best way would be try to explain yourself. Okay, think your logic aloud. Okay, बोल के करो code कि हाँ ये कर रहा है, ये वो कर रहा है. Try to explain it to your friend. Okay, or on a piece of pen and paper. Try to explain to yourself. If you are able to make your friend understand, then it's good, right? I'm probably okay. Preeti, did you try the basic problems? Okay, did anyone try the basic string problems that I shared with you of interview bit? Assuming that you are done with the portal questions. Yes? Okay, so try that. These are also good questions, simple questions, hai, zyada tough nahi hai. But yeah, they will also teach you a couple of good concepts there. Okay. Cool, guys. And guys, one advice that I will give you, whatever specific doubts that you have, right? Whether it be in strings, functions, 2D arrays, whatever, right? Now the open doubt sessions are getting started, right? So I see generally a lot of messages, 11 to 1, 1 to 2, बहुत बार आता रहता है ना दिन में. So try to take your doubts there and get it clarified, right? Those are being arranged so that your personalized doubts can be catered to, right? One on one or two. मेरे को नहीं पता कितने जन आते हैं उसमें, but the idea behind that is that only. So try to attend those sessions. If you have doubts, go and ask the instructor, right? Okay, cool. So I am not writing the code for Fibonacci. Can everybody code it up on your own? Yes? Okay. So now I'll move further. Code लिख सकते हो ना तुम लोग खुद से. मैं code doc में update कर दूंगा. Simple code है. Okay. Cool. Let's move further. Okay. So I see it's almost 83% are in this bracket. So that's fine considering the topic is recursion. I am happy. So, okay, let's stop this poll. No more polls because I've run out of the free trials. Okay. So now let's try to solve some basic, recursion questions, right? Okay. So this is a site. I will share the link with you, right? Coding Bad Java. Okay, we do it every time. Now it contains recursion one. There is a topic here, right? This contains some simple questions on recursions, right? So you can start, you can also solve some questions on recursion from here. Okay. So today I'll try to take a couple of questions from here. And tomorrow, again from 8 to 11, we will only solve problems on recursion, right? Problems based on arrays, strings, all these using recursion, right? Okay. So let's take, right? I'll take simple questions first. Bunny ears lete hum log, theek hai? Let's go to this part. And now you will only help me with the base case with this, right? Now see guys, this is another example of a function completion problem. Dekho, we don't have to worry, and these kind of questions will only be there in the test, right? You don't have to take input, you don't have to give output. It is telling that boss, there is a function bunny ears which will receive an integer. Let us call it bunnies. You have to write your logic and return an integer. You just have to complete this function. These type of function completion problems will only be asked in the test. You won't have to take inputs. Okay. Now let's read the question. We have a number of bunnies. Okay. We have a number of bunnies and each bunny has two big floppy ears. Okay. बहुत सारे bunnies hai, and every bunny has two big floppy ears. Okay. We want to compute the total number of ears across all bunnies recursively without loops or multiplication. So it is telling boss, you have certain number of bunnies. Let's say there are 5. There are certain number of bunnies and every bunny has two big ears, right? Every bunny, forgive my drawing, every bunny has two big ears, right? So it is asking how many total number of ears are there? How many total number of ears are there? So you will ask me, hey, why are we even trying to do it with recursion? It is a very, very simple problem, right? If you have these number of bunnies, what is bunnies? This is telling you how many bunnies are there. So just return 2 into bunnies. Won't that be the answer? Yes. If there are 5 bunnies, you just do 2 into 5 and you will get how many ears are there. There are 10 total ears, right? Because every bunny has 2 ears. But it is telling me don't use loops or don't use multiplication. Try to solve it recursively. That is, bunny ears of 0 should give you 0 because 0 bunnies have 0 ears. Bunny ears of 1 should give you 2. 1 bunny has 2 ears. Bunny ears of 2 should give you 4. 2 bunnies have 4 ears. Is the question clear to everyone? You have to calculate the number of ears recursively and return that as an answer. Okay. Now, how do we think it up recursively? How do we think it up recursively? मैं क्या बोलता हूँ, boss, let's say my n is equal to 5. Let's say my n is equal to 5. That is, I want to calculate the sum of these 5 bunnies. I want to calculate the sum of these 5 bunnies. Okay. Can anybody give me an idea? What can be the recurrence relation? Okay, so the base case is if n is equal to 0, return 0. That's fine, right? Because if there are 0 bunnies, you know what is the answer. Simply return 0, right? What will I tell? Okay. Now let's say n is equal to 5. I want to compute the answer of the total number of years the 5 bunnies have. So मैं पता है क्या बोलूँगा, boss, Can you tell me the answer of these 4 bunnies? Can you tell me the total number of years that these 4 bunnies have? Right? Then you get the answer, you add 2 to that, and that will be your answer. So can I say the total number of years of n bunnies is nothing but 2 plus the total number of years that n minus 1 bunnies have? Can I say this? What is f of n? F of n will telling me how many years does n bunny have. So मैं क्या बोलता हूँ, boss, the nth bunny has 2 years, and then you find the total number of years n minus 1 bunnies have. Okay. So if I want to find the total number of years of 5 bunnies, I tell you, boss, tell me how many years 4 bunnies have. You get the answer as 8. Add 2 to the answer. That is the total number of years that 5 bunnies have. And return this answer to your caller. Okay. So how will recursion work? See, let's say I have called f of 5. Boss, I want the answer. How many years 5 bunnies have? So what I will say? Boss, is 5 equal to 0? No. So I will say return 2 plus f of 4. Okay. So I will call f of 4. I will say how many years 4 bunnies have. What it will say? This is not the base case. So this will say 2 plus f of 3. Okay. Then I will say how many years 3 bunnies have. This will say 2 plus f of 2. How many years 2 bunnies have, right? Now f of 2 will say, okay, how many years 1 bunnies have? 2 plus f of 1. Okay. Now, what will f of 1 say? How many years 1 bunny have? How many years? It will say, boss, 2 plus the number of years that 0 bunnies have. Okay. Now, what is f of 0? F of 0 will return 0. So 2 plus 0 is 2. So f of 1 will return 2. 2 plus 2 is 4. So f of 2 will return 4. 4 plus 2 is 6. So f of 3 will return 6. 2 plus 6 is 8. So f of 4 will return 8. 2 plus 8 is 10. So f of 5 will return 10. Are you understanding how it is working? Yeah, so Bharat, you can have the 2 base cases also. But ideally, if you only have for 0, that also works, right? How many of you are understanding what is happening? Yeah. You can take that. That is also fine. But you have to get this also, na? Because the input can be 0 also. 2 plus f of 4 not here. Boss, tell me. If I say what is the total number of years 5 bunnies have, so ye kya hoga? I will say find the total number of years that 4 bunnies have. Okay. Then add 2 to it. Because 4 bunnies will have 8 years and the 5th bunny will have 2 years. So total number of years that 5 bunnies will have is 8 plus 2, which is 10. Okay. What is f of 0? F of 0 is total number of years that 0 bunnies have. And if there are no bunnies, the answer will be 0 only. Okay. Simple question है, इतना tough नहीं है. ठीक है. Let's try to run it. If it returns 0, then it will be returning 0 again and again. No, didn't get your question. Why again and again? Why again and again? That is the base case, right? एक बार वो 0 return करेगा, उसके बाद you will see f of 2 is 2 plus 0, that is 2. F of 2 will return, f of 1 will return 2, right? Something like this, right? Are you getting what I'm trying to say? F of 0 will return 0. What is f of 1? 2 plus f of 0. So f of 1 is 2. What is f of 2? 2 plus f of 1. So 2 plus 2 is 4. ऐसे करके calculate होगा. Okay. So first let's write the base case. If bunny is equal to 0, okay, what should I return, guys? Fine. Now what should I write? That is not the base case. So I have bunny's number of bunnies. So what do I know? The number of years that bunny's number of bunnies will have is nothing but 2 plus. I will call bunny years. The boss, what is the number of years that bunnies minus 1 number of bunnies have? Do you agree? How to generate formula? That depends on question, right? इधर मेरे को दिख रहा है कि 5 bunnies, the total number of years that 5 bunnies have is 2 plus the total number of years 4 bunnies have. That is what have I done. 2 plus the number of years bunnies minus 1 bunnies have. Is it making sense, guys? Yes? Let's try to run it. Okay, so all correct. So this has run fine. This has run fine. Okay. Can I move to the next question? Yes, it's like trying to make your concepts more clear, right? These are basic questions here. So it will help you in strengthening your understanding. Okay. So let's go to the next question. Let's take bunny years 2. Right. Okay. Now let's read the question and then I'll ask you guys to come up with the recursive code. Spend a couple of minutes reading the code. So you have certain number of bunnies that are standing in a line, right? And the bunnies are numbered 1, 2, 3, 4, 5, 6. Aisa, okay. Now the odd bunnies have normal 2 years, and the even numbered bunnies have 3 years. होता होगा यार कुछ चीज. पैर खड़ा कर लिया, so that raised foot is also looking like a ear. So let's say if you have 5 bunnies, now the bunnies at the odd places have 2 years, right? The bunny at the even places 3 years. ऐसा कुछ. ठीक है. So let's say, are you getting this problem? The bunnies that are standing at even locations, they have 3 years, and the bunnies that are at the odd places, they are having odd 2 number of years. So now what you have to do is you have to tell me the total number of years that n bunnies have. So bunny years of 0, if there are 0 bunnies, you have 0 years, right? If there is 1 bunny, if there is only 1 bunny, right, you have 2 years. If there is 2 bunnies, then n equal to 1 or n equal to 2 pe bani hai, so 2 plus 3 is 5. So you have to return 5. Okay. Can you help me with the base case first? Anybody? Okay. If bunny is equal to 0, return 0. That's fine. Now help me, guys. Help me. Say, if the value of bunnies, okay, let's say if somebody tells you, find if the value of bunnies is 5, right? So let's say you are standing, or let's say if the value of bunnies is 3. So let's say you are standing, you want to find the sum of these 3 bunnies. Agreed? If the value of bunnies is 3, then you have to find the total number of years of these 3 bunnies. So can I say, boss, if you are standing at an odd numbered bunny, okay, the value is 3, right? So you are standing at an odd numbered bunny. So the total number of years of these 3 bunnies will be 2 plus the total number of years these 2 bunnies have. So 2 plus f of n minus 1. Do you agree? If n is odd, if n is odd, if n is odd. Does everyone agree? If n is odd, that means you are standing on a bunny that has 2 years. So what will be the total number of years of these bunnies? 2 plus the total number of bunnies of these. Dekho guys, try to understand. I am saying this is bunny number 1. ऐसे just draw कर रहा हूँ. Bunny number 2, sorry. Bunny number 3, bunny number 4, bunny number 5. So let's say I have to calculate the total number of years of these 5 bunnies. Okay. So I want to calculate the total number of years of these 5 bunnies. So what do I say? Boss, this 5th bunny will have how many years? 2 years. So it is nothing but 2 plus find the total number of years that these 4 bunnies have. Can I say this? What is f of 5? F of 5 is nothing but 2 plus f of 4. Do you agree? The total number of years that these 5 bunnies have is nothing but 2, because the 5th bunny has 2 years, right? Plus the total number of years these 4 bunnies have. But if I ask you, boss, you have to find the summation of these 4 bunnies. Okay. Then what do I need to do? I need to find the sum of the years of these 4 bunnies. So what do I say? Boss, what is the number of years that the 4th bunny will have? 3 now. So what do I say? Boss, the total, if n is even, what will I say? The total number of years that these n bunnies have is nothing but this 4th bunny will have 3 years plus the total number of years of these 3 bunnies. Okay. So if I want to write the recurrence relation, what will it be? If n is even, let's say if n is even, okay, then the recurrence relation will be f of n is nothing but 3 plus f of n minus 1. But if n is odd, then the recurrence relation will be f of n is equal to 2 plus f of n minus 1. Are you guys agreeing? Do you guys follow? Yes? So let's quickly code this up, right? Let's quickly code this up. I cleaned all the drawings. So quickly क्या करेंगे? If पहले base case लिखते हैं. Return 0. Okay. Now what will I check? I have to find the total number of years of these many bunnies. Okay. So if the number of bunnies is even, right? Then I'm standing on an even numbered bunny. So how many years does an even numbered bunny have? 3 years, right? So what I will say, return 3 plus, okay, bunny years 2. अरे बहुत boring काम है. Let's change this. F कर देते इसका नाम, right? So 3 plus f of bunnies minus 1. Okay. Else what will happen, guys? Else what? You have odd number of bunnies? Yes. So return 2 plus. Yeah. This is the last question. We'll stop after this. Making sense, guys? Yes. Yes. Let's try to go it and see. Oh, okay. So we can't change the name of the function. That's somewhere. If you don't get else, no problem. No problem. Even if you don't get else. Okay. But this is the last question, guys. Okay. We'll not discuss anymore. Let's change the name. I thought that maybe that won't be a problem, but yeah, that's a problem. Let's try to run it. Okay. So everything is fine, right? So just let's dry run this question and we are done after this. Okay. So मैं क्या बोलता हूँ देखो, let's try to dry run it, right? So let's say the value of n is 5. Okay. So can you tell me the answer for n equal to 5? The first bunny has 2 years. The second bunny has, what is the time complexity? Big O of n. Big O of n, right? The second bunny has 3 years. Okay. The third bunny, again, it's an odd, so 2 years. Okay. The fourth bunny will have 3 years and the fifth bunny will have 2 years. So if n is equal to 5, what should be my answer? 2 plus 3 plus 2 plus 3 plus 2. Does everyone agree? Answer should be 12. Mante ho kya? Yes. Now let's try to run it, right? So I will call f of 5. I will call f of 5. I see there are 5 bunnies. So the number is odd, right? So the fifth bunny, because n is odd, the fifth bunny will have 2 years. So what I will say? This will say return 2 plus f5 is odd now. So it will say return 2 plus f of 4. See, boss, this bunny has 2 years. Now can you give me the summation of the first 4 bunnies? Okay. Now what will happen? F of 4 starts running. You have 4 bunnies, right? So now I am standing on the fourth bunny. Think of it like I am standing on the fourth bunny. So 4 is an even number. So I know that the fourth bunny will have 3 years. So what it will do, f of 4 is nothing but 3 years for this bunny plus get me the summation of these 3 bunnies. So f of 3. Now what will f of 3 do? F of 3 will say, okay, 2 plus f of 2. Okay. What will f of 2 do? F of 2 will say 2 plus f of 1. Okay. Now, what will f of 1 say? You have, मैंने कुछ गड़बड़ कर दिया क्या? F of 3 says 2 plus f of 2. Now what does f of 2 say? F of 2 will say, boss, there are 2 bunnies. So the second bunny has 3rd year. So 3 plus f of 1. Okay. And what will f of 1 say? F of 1 will say, boss, there is only 1 bunny. Okay. So 2 plus f of 0. Okay. And what is f of 0? F of 0 is 0. So this returns 0. 2 plus 0 is 2. So f of 1 returns 2. 3 plus 2 is 5. So f of 2 returns 5. 5 plus 2 is 7. So f of 3 returns 7. 7 plus 3 is 10. So f of 4 returns 10. 10 plus 2 is 12. So f of 5 returns 12. Okay. Yes, if else will be applied in every case. Either if में घुसोगे या else में घुसोगे. Making sense, guys? Yes. Okay. So cool, guys. I think today we have discussed many important concepts, right? So that should be it. Okay. We'll not extend the class any further. It's already time and most of you are over exhausted. So let's stop the recording.